I'm making a new series of Roblox game development tutorials about Lua scripting. Each video will be under 5 minutes, as the name implies. There are some stuff I'm going to assume you already know, like very basic math like addition, subtraction, whatever, and division. I'm going to assume you know how to download Roblox Studio and the very basics of playing Roblox, I'm assuming you have played Roblox before. If you really want me to make a video about downloading Roblox, I guess I can do that easily in less than 5 minutes, but I think you guys got this. And I'm assuming also you have a laptop or a desktop because you need that for Roblox Studio. Some things I want to say. The main focus of this course is scripting, but I will show you some of the other stuff along the way, but the focus will be on scripting. We won't actually script until video number 5 because I want to get some of the things out of the way to make sure we're all on the same page. But you can just, I guess if you really want to, you can skip to that, or maybe just watch the other videos. Maybe you'll learn something, you know? I have 60 videos that I made, and they're all less than 5 minutes. So if you do the math, not including this one, the other 60 videos should take you less than 5 hours to complete the whole series. And there are projects every once in a while in the series, and I'll try my best to make them involve like everything we covered in the previous sections. This series builds on top of each other, like you'll need the stuff you learned earlier to progress in the later parts. Why did I do this? Well, I wanted to do a series, and honestly, this is my first one, and 5 minutes. First of all, it'd be easy for me, which I need something easy to do because I've never done a series like this. So it's a good place for me to start. And also, I feel like people think scripting is harder than it is. I'm hoping I can show you it's not if I could clearly explain many concepts in less than 5 minutes each, you know? And third reason, there's many people that want to like become a game developer or whatever. And all the information is out there on the internet if you go look for it. But a big problem is discipline and motivation. I think you should start off with like the baby steps that you can handle, and then you can go on. Like it's scary to jump into like a 30-minute video explaining a concept or an hour video. Maybe all your discipline allows you to do is 5 minutes at a time. If that's the case, I want you to be able to have something you can watch, you know? Maybe you could only handle 5 minutes a day, and I think that's great. If you only do 5 minutes a day, I mean, it's not ideal, but I think it's something the majority of people can handle. If you just do this series for 5 minutes a day and you know like nothing about scripting, it'll take you from knowing nothing to being able to handle pretty much anything in just 2 months or 60 days. This series isn't going to teach you everything, obviously, but it will definitely take you from knowing like nothing about scripting to make you comfortable with it. My goal is by the end of the series, you'll know enough that you could easily jump into any other subject. Now you know, oh, I see this takes in a value. I know how to instance it. I know how to, you can put together the dot. How do I think you should go about doing this course? Well, you can do whatever you want, obviously, but if it was me taking this course, I would, after each video, I would do 1 to 3, preferably 3 projects on my own using what was covered in that video, even if it's simple. The more things you involve of what we learned in the past videos, the better. Like we just watched a video about printing. Well, even if it's simple, like print a few things, make your own little projects, you know, come up with your own idea and try to do it. Even if it's simple. I know it might not be possible for the first few videos because the subjects are too simple, but maybe after like printing, you can go from there. But again, you can do whatever you want. I'm not your mom. When you first open Roblox Studio, it might look a little something like this. You have a lot of stuff going up on here and on the sides and everywhere. This top part we're going to leave as is. Everything else, I'm just going to close it to show you how to pop everything back up that I'm going to be using. And if you want to set your thing up like I am going to have mine set up in this series, then follow along with what I'm going to show you. First, I'm going to go over these tabs at the top right here. The first one is the Home tab, and it has some of the most used tools that you'll be using very commonly if you're developing games. It lets you manipulate and add objects, and it also lets you test your game out. The Model tab lets you further manipulate parts, and you can see some of the Home tab features like these tools over here. But it also has a lot more than you saw there too. The Avatar tab we are not going to really be using, but as the name implies, it's just for messing around with avatars, which are like characters and stuff like that. The Test tab lets you run and play your game so you can test it out. For now, we will only be using the play/run over here, but I will show you some other stuff in the future, maybe. The View tab controls what you can see on Roblox Studio, and we'll get back to this when we actually add all the other things that I made you close out at the start. The Plugin tab, we were not going to be using this either, but it lets you use user-created features, which are known as plugins, to help you develop. But be careful because some of these plugins can mess with your games. They're referred to as viruses sometimes, so make sure they're reliable. But the popular ones that you see have a lot of favorites and likes, they should be fine. Alright, so I deleted my stuff by exiting out of everything, and I'll show you how to add those back in case you don't have some of them, or if you want to put them exactly like I have them set up for the series, I'll show you how to do that too. First, you'll want to go to the View tab because that's where most of the stuff is going to be. You're going to need the Explorer tab for this series, and I'm going to keep mine on the right side. If yours is somewhere else, just grab in this little rectangle where the name is, and you can see this little cross in the middle. Put it all the way to the right side. That's where I'm going to have mine. The property section is going to be on the left side. Again, if yours isn't right there, just go ahead and grab it to the cross all the way to the left side. For the output, you're going to want to click this little icon here, the second one in the top row. And I want mine to be right underneath the properties. So hover it over the properties box and put it right underneath. I'll make mine a little thicker. And something that we're not really going to be using, but I always like to have, is the command bar. Yeah, we won't really be using this, but if you want to have yours looking like mine, just go ahead and add that. It doesn't take up that much space. You'll be fine. Something else that I have is this little icon up here. It just shows you how the camera is oriented in the world. If you want that, just click the view selector right here in the action section. The command bar is optional, and so is the view selector. The view selector is optional. And the last thing that I have is in the model tab. It's this insert object thing, which lets you insert objects. This is also optional, but I like to have it. I used it from back in the day, so I just like to have it. And I don't want it taking that whole bottom section. It does not need to be that big. So I just keep it in the middle section like this. Drag it to the cross and to the bottom, and bam. This is going to be the setup. Feel free to adjust this and adjust this however big you like. It should be fine like this. So that's how you do it. There are many ways of inserting a part. One method is to go to the Home tab and to click Parts right here in the Insert section. And you can see by clicking that, it added a part in the world. If you don't see this little box section and you see a different part show up in your world, you can click the little drop down and select Block. That also adds in a part, as you can see. And it changes this to be block. Like if it was something else like wedge, then we go back to block. Now whenever we click this, it'll be the block instead of the wedge. This same exact thing can also be done from the model tab in the part section. It's the same exact tool. Another way to insert a part is through the insert objects thingy that I told you was optional, but if you did choose to insert it, just type in part, or if you already see it, just click on it and it'll add it into the world. Finally, and probably the most common way to add a part is to go over here in the Explorer window. Right next to the workspace, if you hover over it, a white circle with a plus sign inside of it will appear. Just click that and you can either see it, the part right there, or if you don't see it, begin to type it until it appears. Just click on it. It doesn't have to be inside workspace, but if you want it to appear in the world, then yeah, put it in workspace. To delete parts, you can click on them and then right click and then you can hit the delete. Or another way, if you want to delete multiple parts, you can click and hold down on the mouse, select over multiple, and then delete it that way. Instead of right clicking, an easier way is just to hit the delete button on your keyboard. Also, if you don't want to box select, but you still want to select multiple things, you can hold down shift and click on the parts individually and it'll select all of them. And then you can delete them. Let's just delete these three for now. If you select this part, either box select or just clicking on it, and press F, the camera will teleport to whatever you have selected, which was the part in this case. We just selected it. To traverse in the Roblox Studio world, you can right click and hold and move the mouse, and this will change the angle of the camera. You can use the scroll wheel to zoom in and out. You can also use the middle mouse button if you have one and click down, and that'll move the world around like a translation. But I don't really use this because a better way is to use the W, A, S, and D to move around the world. You could also use the Q to go down and the E to go up. But sometimes this is too fast, so for all those directional keys, you can hold down shift and it'll move in smaller increments. Nice and precisely. The Explorer window, which I have placed on the right over here, is what organizes everything in the game. These big boys you see over here, like workspace, lighting, players, all of this stuff, all the way down to test service. These are what are known as services, and they control a certain aspect of the game. For example, the lighting, guess what? It controls the lighting. Wow, who would have thought? Let's take a look at workspace right now. If you click the little triangle thing, you can see the things that are physically in the game, like this base plate I have, and also this regular part is in the game. And you see when I click on it, it selects it in the game. And if you remember in the last video, I told you to add it into the workspace. That's why I told you click the plus next to the workspace, because if you want anything to be seen in the game, it's going to go in the workspace. So we're going to be dealing with this a lot during this series. The player service, when a player joins the game, their player object, which is kind of like, I guess, their soul. It's not really their physical character that's in the game. It's like their player object. It's like their soul. Just think of it as their soul for now. The lighting controls general lighting, obviously. This includes things like the time of day and the brightness. Like the sun is right here in this position because that's what the lighting said to do. Server script service. This is a place to hold all your regular scripts. We can also put them in workspace. It doesn't really matter too much for the sake of learning. I think it's better practice to put them in server script service, but don't rely on me to do that every time, because I'm just not, okay? I'm just not going to do that. Don't rely on me to do the right thing, because I will let you down. Server storage. This is for things that you want to use, but maybe not at every single moment you want it loaded in. Like maybe a map. You're having a round-based game that has different maps. You don't want every map to be loaded in. That's just making everybody laggy for no reason. You can store the maps in here, and then when you need them, move them to the physical world in workspace. Let me show you with the part. Let's say this part represents the map, and we're in intermission right now. So we can just move this to server storage. And bam, it's not bothering anybody right now. It's not in the way, it's not visible. But when we're ready, oh, everybody voted for this map. Bam, we bring it back into the workspace. Pretty cool. Starter GUI. This is where you put GUIs, graphical user interface, which are those things that show up on your screen begging you to buy Robux. That's what goes here. You know what they are, you've seen them. We will learn more about these in the later videos, so if that's something that interests you, make sure you watch every single one of these videos all the way through 5 times, because you never know which one of those is going to be the one you want to watch, you know? Except if you read the title, you probably will. But anyways, in Roblox, there is a hierarchy. Objects are placed inside of each other, just like how the part is inside of workspace. That means that a workspace is the parents of part, and the part is a child of workspace. It's a parent-child relationship because we literally put it inside. You see how it's indented over? Everything that's indented over is a side of that. For example, if you look at starter player, these are indented, so those are inside of it. These are the children of starter player. If I move the part to be somewhere else, like I did earlier, if I move the part to server storage, now the part is a child of server storage. It's indented underneath that. Also, let's say for some reason this part is inside of this part, which is inside of workspace. You could say that the second part that's inside of the part is a descendant of workspace. Even though it's multiple generations down, it's the child of a child, it's still a descendant. And one last thing, it looks like every object has to be parented by a service. So like this part is inside of workspace, or it's inside of a different service, or it's inside of another part, which eventually leads up to a service. So it might lead to the illusion that services are in charge, but they're really not. All of these services are children of a bigger thing called game, and you'll see how that's relevant in the future. I know I hate saying you'll see how this is important in the future. I hate when people do that, but this is the very beginning. Okay, relax, we'll get there. It'll all make sense very soon. Just keep that in mind, okay? You do that for me? Thanks. A property is a value that affects the appearance or behavior of an object in Roblox. This sounds a little bit confusing, but it's really simple. When you have nothing selected, as I do right now, the properties window is blank. But pretty much every object in Roblox has properties, but you have to select it to see it. So just click on this part, for example, and now we can see all the properties that it has. You can even scroll down because there are a lot. Even the services, like if we were to click on workspace, it has properties. Many objects and services have properties in Roblox. I'm going to go over some of the most common properties for parts. First, let's look at brick color. This is just a way to change the color. As you can see, I'm hovering over it. It won't actually change it until I click on something like artichoke. These are built into Roblox, pre-made colors like artichoke. But another way to change the color is through the color property. This is brick color, and this is color. The color takes in an RGB value. If you don't know what that is, that's just how much red, how much green, and how much blue is in the color. For example, if we put it all the way up to here, it has a lot of red, but not much green or blue, and that's why it looks red. We can make it brighter and darker over here, or we can just select some of these over here. But yeah, you can drag this little thing anywhere you want to get any color you desire. The material property, it's just a list of different materials, and you can pick them out, and they're pretty cool if you ask me. Like, let's take a look at cracked lava. Ooh, that actually looks nice. Look at that detail. Another common property is transparency. It takes in a number 0 to 1, 0 being completely not transparent. As you see right now, you cannot see through the part. But if you make it 1, it becomes completely transparent. You can't see it at all. It also has this slider that you can slide to any decimal value in between those two. Like if you want it 50% transparent, just leave it at 0.5, and now it's semi-transparent. The locked property matters a lot when you're dealing with game development. If we check that box off, that means that when we click on it or box select it, we cannot affect it. We can only get to that part by clicking it in the Explorer window. Similarly to the base plate, I can't interact with the base plate at all unless I click on it in the Explorer window. That is what the lock property does. And then when we uncheck the box, we can now select it again. We can box select it like usual. The name property just changes what the part is called. We can call it, I don't know, we call it Moses, and it'll change it in the Explorer window because it is the same part we're dealing with here. It's all the same. You can make it whatever name you'd like. That's appropriate. The parent property we talked about last video, like, oh, I moved it over here and that changes the parent, but you could also change it. Instead of dragging it in the Explorer, you can just click on here and then click server storage and move it over there, and then you can click back to workspace. Just a different way of changing the parent. The size property, it takes in 3 number values. One for the x-axis, so let's change that to 14. You see how it gets longer. One for the y-axis, change it to 11. See how it gets taller. And one for the z-axis, change that to 12. See how it gets thicker. Or that's 21. I'm dyslexic. Position has to deal with the same 3 axes. If we set it to 0, 0, 0, that will take us to the middle of the world or the origin. If we move it 10 over, then you can see it moves it in the x-axis 10. If we move it 20 in the y-axis, you can see it moves it up in the y-axis 20. And let's say we move this to negative 30. It moves it in the other direction. If we do 30, it moves it in one direction if we do regular 30. But if we do negative 30, it moves it in the other direction. Orientation, this is just how rotated it is. Again, let me show you with 15 in the x. It angles it in the x-axis. 30 in the y, rotates it 30 degrees in the y-axis, and then let's do 45 in the z, tilts it 45 in the z-axis. Can't collide just determines if parts can bump into it, basically. I'll show you what I mean. Right now, can't collide is checked to true, so when the game is played, the part falls down on the base plate because it can collide with it. If we set that equal to false and play the game, the part goes right through it because it cannot collide because we checked it off. Last property we're going to look at is anchored. Right now it is checked off. So when it's not anchored, the part just falls down like normal. And when we set that anchored equal to true, the part will not move. It cannot be pushed. It cannot be pulled. This part is going to stay right here no matter what force is acting upon it. It is anchored in place. So to insert a script to workspace, we can use the insert objects like we did for the part. Just instead of writing part, obviously you want to write script, and when you find it, click on that regular script with the white icon, and you can either have it highlighted and press enter or click on it, or you could also use the method with the plus sign and just click the script. But for scripts, there is another way. Just go to the model tab and click this little white icon, and bam, you have yourself a script. Right now, we're inside of the script. If we want to switch back to the real world, we can just click right here where it will say the name of your place. In my case, it's called tutorial place. But if we want to go back to the script, we click this little tab right next to it, and now we're back in the script that we just added. Also notice when we're in the tutorial place, we're in any one of these tabs. When we're in the script land, we're in the script tab. So the options up here are different too. So you can already see it says print hello world in this line of code. It's the first thing people do when they learn a programming language. But I'm a terrible person and I made you wait like what, 5-6 videos before you can even begin to script, but my bad. So what does this do? I'll show you. A script is only running when the game is playing. If you hit the play button, it will put you in the game. And if you don't see that, just click the drop down menu and you can see the play button right here. Because I don't have the play one, I have the run one. So let's just click play for now. Or as you can see, you can hit F5 on your keyboard as a shortcut. So just go ahead and click that. And as you can see, I can run around in this place. It's like I'm playing the game, but I'm really not. I'm just testing it out. But it's, for all intents and purposes, it's the same thing as if you were playing. However, you don't need to have your character out for what I'm going to teach you right now. So you can just hit this little red square at the top, or you can hit Shift F5, and that'll also stop the little game testing. We'll go back into our script world and we can just hit the run option. What this does, it plays the game but without your character. So it loads faster because it doesn't need to load in your character. And we don't really need the character for this lesson. So we're just going to go ahead and hit run or hit F8 on your keyboard. And when I hit run, I want you to focus on this little output window and see if you notice anything. You see it says hello world, exactly as it's written in our little script within the quotation marks. I'll tell you what the output window does. This is just a way that the script communicates with us. It also tells us the time things were printed at. Like I just happened to run this at 14:38 and 33 seconds, so 2:30ish in the afternoon. And it also tells us exactly what was printed. And what we printed was what it's inside the quotation marks, which was hello world with an exclamation mark. Finally, it also tells us what line of the script it was printed on. It tells us this one right here. And as you can see, we're on the first line of the script. To print something, you have to follow this syntax. And syntax is just like the blueprint, the layout, sort of. I'll start it from scratch. You have to write print. Then you have to add parentheses and quotation marks. And whatever you write inside of the quotation marks will be printed out. If you write subscribe, you have to, don't forget to stop it and restart it. And you see, I wrote subscribe inside the quotation marks, and that's what is printed out. You can print just about anything you want. You can write entire sentences if you want. You can even write lies. As soon as you test it out, it'll be printed in the output. So back to our script where I told you anything inside the quotation marks will be printed out in the output. So let's do 3 plus 2 and see what happens. It prints literally 3 plus 2, exactly what we wrote in the script. The script can print out arithmetic, but to do this, we have to get rid of the quotation marks. And now it works like regular math. See, print 3 plus 2 without the quotation marks. And bam, 5. Comment down below if that's the right answer. I don't know. So when we want words to be written, we use quotation marks. Or if you actually want to print 3 plus 2 instead of the answer, you can use quotation marks too. But when we wanted to do math or something like that, we do it without the quotation marks. So when you want to write exactly what's in there, put the quotation marks. If you want to do math, no quotation marks. Let's see what else we can print. Okay, so you know that using the plus sign adds things together. If we use the minus sign, it makes subtraction happen. We can even use the negative sign for negative numbers, and it'll print out -5. To multiply, we use the star symbol that's right above the 8. When you press Shift 8, that symbol. So 3 times 2 is what is going to happen. 6. And for division, we use the little slash symbol. And this is saying 3 divided by 2, which is 1.5. And if you press Shift 6 and look at that little symbol, it's the caret symbol. And that is for exponents. So this is 3 to the power of 2, which should result in 9. For this, the order matters, because if you do the 2 first and then the 3, then that's 2 to the power of 3, which is 8. There is another symbol I want to talk to you guys about. It's a little bit tricky, but bear with me, it's not that bad. That little percent symbol, it's also known as modulus. What this does is to find the remainder of any number. For example, if we divide 3 by 2, then it goes into it 1 time, so the remainder is 1 because 1 is left over. 2 goes into 3 1 time and it has a remainder of 1. So the answer is 1 because it prints out the remainder. If I do 5 modulus 2, what is the remainder for that? Hopefully you know that it is 1. Doing things by modulus 2 is a great way to see if a number is even or odd. If a number is odd, it prints out 1. And if the number is even, it prints out 0. For example, 5 modulus 2 has a remainder of 1. But if we do an even number, like 8, when you modulus it by 2, I don't know the proper term for that, it should have 0. Any even number will result in 0 when modulus by 2, and any odd number will result in 1. We can find if any number is divisible by any number. For example, let's say if you want to see if a number is divisible by 3, just use modulus 3. And we can type in any number in the world, and I can tell you if it's divisible by 3, if this results in 0. Oh, it does result in 0. I just wrote in a random number and it worked. What are the chances of that? 1 in 3? Yeah, whatever. But yeah, this big number is divisible by 3 because we modulus it by 3 and got 0. The last thing I want to show you is the use of parentheses. If we do 6 divided by 2 plus 1 and we print out that answer, it's 4. However, if we put parentheses around this part, and you know how parentheses work, they just do whatever's in the parentheses first. Before it was doing orders of operation, so 6 divided by 2 first, which is 3, plus 1 is 4. Now it's going to do whatever is in here first, in this case 2 plus 1. It'll do that first, and let's see how that changes the answer. See, now it's 2. So parentheses are important to make things work how you want it to. If you want a certain part to go first, make sure to put it in parentheses. First thing I want to show you, if we write hello world, or what, if we write anything, we can print out multiple things. We can print as many times as we want. The script will add lines as you keep adding them, and it'll do whatever is in the script as many times as you tell it. If we do it 3 times, guess what it's going to print? Hello world 3 separate times. If I print hello, then world, then exclamation mark, guess what it's going to print? Hello, then world, then exclamation mark. Because scripts go in order from the top to bottom, beginning to end. So that's why it got printed out in the same order that we wrote it in. However, let's say I wanted to wait a few seconds between each print. I could easily do that by just writing wait, all lowercase, and in parentheses writing the number 2. And we could do it again here. So it's going to print hello. Then it's going to wait 2 seconds. This value is written in seconds. And then print world. And then wait another 2 seconds. And then print exclamation mark. Let's see that happen in action. Hello, world, exclamation mark. You could even wait decimals if you want. You can wait 2.5 seconds. Or maybe you just want to wait 0.75 seconds, 3/4 of a second. It doesn't have to be a whole number. I'll show you. Hello, world, bam. You see? And if for some reason, you could even do calculations in here, like 3 minus 2 seconds, which is 1 second, or I don't know, 3 modulus 2, which also happens to be 1 second. This will eventually boil down to a number, so anything that boils down to a number, you can put in there. Hello, world, exclamation mark. Also, let's say, I really wanted to wait 3 minutes, but I don't feel like figuring out how much 3 minutes is in seconds. Doesn't matter, just write whatever minutes you want and multiply it by 60. That's what a minute is, 60 seconds. So this will wait 3 minutes, and I'm not going to show you that. I only got like, what, 5 minutes? I'm not going to have enough time to show you that. This is all nice and dandy, but it's a little old school. All the cool cats, they write task.wait because it's more exact or something. I don't know, don't ask me. Don't ask me, but this is what all the cool cats are doing. So just write task.wait. It's like better, it's more better. Okay, so just do it. You probably won't see me doing it. I'm a dinosaur, I'll forget. Like dinosaur, like I learned long ago, not like I'm as old as a dinosaur. I'm like I'm a relative time. Anyway, if you want to print multiple things on the same line, you can do that. You just have to use commas. For example, I write hello, and then I want to print out something else, like world. Then I want to print out exclamation mark. You can also do that. Just separate each quotation with commas, and they'll be spaced out. This could be a little bit more useful later, but I just want you to keep that in mind. There are many data types we use in Roblox. And actually, we've sort of already used one of them, and you probably don't even know what a data type is. Data type is basically just a kind of value. For example, when we looked at the parts properties, some of the properties were numbers, like the transparency. Some were text, like the name. Some were colors. Those are all data types. It's just a classification of values. In this video, we'll take a closer look at one of those, numbers. If we write a number, obviously that's a number. I just want to show you some more examples of everything to make sure that it's clear. If we take two numbers, like 21 plus 17, this will boil down to a number. So I guess this counts as a number 2. Not a number 2, but a number also. I'm just going to put this print statement here so we don't get the little error. Everything I'm going to show you in this video is going to result in a number. Even if we do something crazy like 3 plus 2 plus 4 plus 7, it doesn't matter. We can do this as much as we want. All the crazy math divided by 2 times 7, it doesn't matter. It will be a number. I just want to be really clear on everything. Even if we write blah, 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 this giant thing, it's still a number, even though it's a little wild, I admit, but it's still a number. Even if we write 3.14159, that is a number, even though it has a little decimal, it's still a number. And yeah, I stopped at 9 because I only know up to 9. Okay, I did my best. What comes after 9? I don't know, maybe like 6, 2, maybe like 2. I don't know. I did my best. And let's play a game. Let's play, is this a number? Even though it's negative. Yeah, it's still a number. If it looks number-esque, it probably is a number. And numbers are used for calculations and properties. Like I told you before, transparency is a great example that uses a number. So it'll be clear on this data type, and all this stuff that I showed you boils down to numbers. So if you ever need a number, you can use any of the stuff. You could do like math for a number. You can make it negative. You can do decimal. All this stuff counts as numbers, so don't be scared of it. Strings are a data type that essentially can be explained as text. When we print something with the quotes, that is a string. Anything we write within quotation marks is automatically a string, and you can tell it's a string because it turns green. Just like with the numbers, they turn orange in my case. It might be a different color for you if you customized it, or if I customized it and I don't remember. But yeah, in my case, strings turn green. That's why we always have to use quotation marks when we print something. Without it, it doesn't know that it's a string. But with the quotes, it knows that it's a string, then it can print it out because the print statement needs a string in it to work, or else it doesn't know that it's text. So anything surrounded by double quotes is a string. However, another method of making strings is using single quotes, like this. A reason we can do this is if we want double quotes inside of our string. Like if I want a string that says, he said hello to the cat. If I did double quotes with this, you see how the string gets confused? It thinks that the string is from here to here, and then there's another one from here to here. Because it sees the first double quote and looks for the next one to stop the string. But if we use single quotes, then it just ignores the double quotes altogether and looks for the next single quote, and the whole thing can be converted into a string as expected. But I can see some of you being like, oh, what if I wanted to use double quotes and single quotes? Like, let me think of an example real quick. What if we had this and we wanted to make this into a string? He said hello, you're amazing, to the cat. What if we had this and we wanted to turn this into a string? But we can't use double quotes because then it stopped right here. We can't use single quotes because then it stopped right here. Well, first of all, you have really nice grammar. Second of all, there's a third method of making strings, which is using double square brackets. Use double square brackets, and bam, it's also a string. And all of these methods work the same. They all do their job the same. So it's up to you on what method you want to use. And also, using this method is kind of a flex because a lot of people don't know about it. It's kind of a flex, so keep down the down low, you know. Strings are used for properties such as names, and we also use strings whenever we print something. And even when we print numbers like 7 plus 2, remember we did that? Behind the scenes, it gets converted to the string after the calculations are done. So I'm not lying, okay? It just gets converted into a string. If you come from another programming language, this is a big relief, right? Lua is pretty cool. Booleans are a simple data type. It's either true or false. It's pretty simple. I don't know what else you want me to say. That's pretty much it. So to write this, we either write true or we write false in all lowercase. An example of a property that uses this is the can't collide property. It's either true or it's false. It's either gonna collide into something or it's gonna go right through it. Those are the only two options. Same with numbers. When we print a Boolean, it gets turned into a string behind the scenes. I'll just show you that if you print false, it goes through fine as false without any problems, even though we didn't make it into a string. And something else I want to talk about that's not true. I know, I said Booleans are only true or false. This is like its own separate thing, kind of. It's called a nil. Now, the thing about nil, it's used to symbolize nothing. Not zero, not false, just nothing. For example, if I want to print out faith with no quotes, not a string, just the words, we get nil because the script doesn't know what this is. It doesn't know if you want to print out faith, if faith is something else. It doesn't know anything. It's as good as nothing to this script. It has no idea what's going on and prints out nil because it's nothing. We didn't make it into a string. You see, the print statement needs a string. If we leave it without the quotation marks, the script doesn't know what faith is, which is kind of sad. But anyways, I told you that the print needs to have a string in the parentheses. And since we didn't make it into a string, it doesn't know what faith is. So it results in nil. If you don't give the print a string or something it can turn into a string, it's literally as good as nothing. Nil is nothing. Variables are a container that hold a value. For example, if I write pi equals sign 3.14, this is a variable and they always follow this syntax. You always write the name of the variable followed by an equal sign and the value assigned to that variable. This is known as declaring a variable. We're basically telling the script, hey, pi is now equal to 3.14. And from now on, whenever we write pi, it holds a value of 3.14. So if we write print pi, it'll print out 3.14. If we didn't declare a variable, you see we get the little red underline for the error, and it prints out nil because it doesn't know what pi is. That's why we have to declare. We have to let it know, hey, pi has a value. It's all right. I'll give you another example so you can see the syntax of declaring a variable. If we type in sum equals 3 plus 2, and you can name your variables pretty much anything you want, by the way. Now, when we print out sum, what do you think it's going to print out? If you guess 5, you're a lucky duck, because you're right. Let's try to print out sum before we declare the variable. Let's see what happens. Nil, because remember how I told you scripts go in order from top to bottom. So it's going to print out sum, but it doesn't know what sum is, so it can't really do that. However, how we had it before, sum equals 3 plus 2, and then print sum, it's like, oh, I know what sum is, it's 3 plus 2. We did that earlier in the script. If you do it earlier in the script, then you can use it after, but you can't use a variable you haven't declared yet. Variables don't have to be numbers. For example, if we write best YouTube channel equals eyes of faith, and then maybe we have another variable. It can be like, I don't know, honesty equals false. It could be any data type or any object, but something I want to go over is the best practices for naming a variable, which is camel case. That just means if you have a variable that has multiple words in it, the first word should always be lowercase, and there should be no spaces, no underscore, but you put it all together, and the next word should start with a capital, and the next word after that with a capital. See, you see the camel, you see the camel shape, like, ooh, this a hump on another hump, you see? Camel. Variables can also be changed. That is what their names mean, variable, able to vary. For example, if we make favorite number equal to 17, and then we print out favorite number, we can later set it equal to something else like 21 and then print the same variable. Even though we are printing the same variable, we changed it. First we set it equal to 17 and then we printed out that variable while it was equal to 17. Then we changed that variable to equal 21 and we printed out that variable while it was equal to 21. So that's why it prints 17 and then 21. One of the biggest reasons to use variables is if we change our minds about something, instead of changing it everywhere, we can just change it once. For example, maybe I had like print 17 like this, and I had it a million times. But then I'm like, wait a second, 17 sucks. I like 21 now. Then I have to go in by hand and change each everyone by hand. No, make it a variable like this. And then when I get sick and tired of 17, I can just change it to 21. And I just had to change it in one place instead of all these other places. You see, it works. It's that easy, man. One last scenario I want to show you. What's going to happen here? I have happiness equal to false. Then I set happiness equal to true. And then I print it. What's going to happen? It prints true. Hopefully you got that right. It doesn't matter that it was first equal to false. We didn't really do anything with it while it was equal to false. By the time we actually did something in line 3 to print it, it was already equal to true. And that's what matters. It doesn't matter what it was before, it matters what happens at the time of the action. Because remember, scripts go in sequential order from top to bottom. Okay, this is the first project in the series. I'm going to tell you what I want you to do, and then I want you to pause the video and try to do it on your own, and then I'll show you my solution for it. And that's how it's going to be for all the other projects. So the first thing I want you to do is make 3 variables and name them answer A, answer B, and answer C. I want you to make the value of answer A the answer of this question. Do you like milkshakes? This is a yes or no, so I want answer A to be equal to a Boolean based on your answer of whether you like milkshakes or not. So the answer, I want this to be a Boolean. Hopefully you remember what that is, a true or a false. So the question of do you like milkshakes? Make it equal to true if you do, make it equal to false if you don't. Answer B, I want you to set it equal to the answer of where would you like to travel to? And this is going to be a place, so that's more like text. So I want you to answer that, assign that as a string, whichever method you like. Answer C, I want you to assign this to the answer of an expression that is equal to 7. So it doesn't matter if you use addition, multiplication, even exponents, I don't know what you're up to. And I want you to make it equal to 7. You can do it as complicated or as simple as you want, as long as it boils down to something that is equal to 7. And this will be a number, of course. After you do all this, after you have answered those questions in the variables, I want you to print out each variable, like print out answer A, then B, then C. but I want you to wait 1 second in between each one. So pause the video now and try it on your own, and then I will show you my solution for it. So the first thing is to make 3 variables, insert A, and do I like milkshakes? I'll set that equal to true because I love milkshakes. Next part, insert B, and this is where would I like to travel to? I'd love to travel to a lot of places. I'll say Japan. Who doesn't want to go to Japan? And last one, insert C, make that equal to an expression that boils down to 7 to 21 divided by 3. So that's what I wanted. Yours should look like this a little bit, hopefully, if I was clear. And now we have to print each one out. Print answer A, but we have to wait 1 whole second in between each one. And print answer B, and then wait 1 second again, and print answer C. And now we're gonna run it, and hopefully it prints out true Japan 7. Waiting 1 second in between each one. True Japan 7. There we go. This is our first project, and there's a few more to go. I hope you did well with this and these videos are helping you. If you watched the other video, then we spent about an hour together, give or take, and I really hope these videos are helpful and you have a nice day. Commenting helps us organize our scripts, and it lets us add text that has no effect on our script. One way we can do this is by adding 2 minus signs or dashes, whatever they're called. We add those before anything we want to comment. I'll show you this by using our last project as an example of why comments can be useful. For example, they're really useful for being headlines and labeling sections of your code. Like if you write 2 hyphens or 2 dashes and write variables, and now we write down here, I don't know, printing, and you see how nice and organized and pretty this looks? Looks so good. This is especially important for other people reading your code because now they don't even have to read all the specific lines. They just know, oh, this section is for variables and this section you're probably going to be printing. Even if they're not, sometimes it'll be like months before you look at this code again, and then you're going to be like, oh, I don't want to read all this code, especially if you have like hundreds of lines of code. Like, I don't want to read all this code to remember what it does. Oh wait, I don't have to because I labeled with the comments because I watch this YouTube channel because I'm amazing. So yeah, commenting can be a great way to help you remind you of what the code does and just keep everything organized and pretty. Another method to comment is instead of doing the 2 dashes, you do 2 dashes and then 2 square brackets to open and then 2 square brackets to close. This lets you use multiple lines. Like if I decide to close down here, all of this will be commented out. So this isn't affecting the code at all. If I run this, you see nothing gets printed because it's commented out. It's like it's not even there, but we can see it, but the script doesn't really care about it. One common example of this is if you like get a model or a plugin of some sort, and then there'll be like a readme, then it'll be like, oh, made by super cool scriptor with like a 0 in the name or something. I don't know. And then it'll be like, thank you so much for installing my plugin. Make sure to like or whatever. And like it expands multiple lines. And then it has like some cool design, like, I don't know. Another common use for comments is to exclude part of our code to see what happens. You're like, I want to see if I like this script better without the waiting. And instead of removing it, you can just comment it out and test it. You're like, actually, I liked it better before. So now we can just bring it back like that. So you don't have to delete parts of your code if you want to test it without it. Just comment it out. And if you have like a big section you want to comment out, use the square brackets and you can comment out multiple things easily. But another way to comment a lot of stuff easily, you select it and then you go up here where it says toggle comment, and it'll either comment it out or uncommented if it's already commented. And the shortcut to this is control and then slash. So that's it. We have already looked at changing parts properties in Studio, but we can also do it via script. First, we need to access the part. In the hierarchy, I mentioned that everything is inside game. So we start from broadest to most specific. I'll show you what I mean. Just type in it game, all lowercase like that. And then when you want to go down a level, we used the dot. Like I want to go to a child of the game, so I write dot. And now we want to go to workspace because that's where the part we want to access is. And you type it exactly as it's written in here in the Explorer tab. And then the next step is part. So that all the services are inside of game, including workspace, so game.workspace. and the part is inside of workspace. So we write dot part. So we start out broad and go from child to child until we get to the part that we want. If the part happened to be like in a lighting or something, we would type game.lighting.part to access that part, but we'll keep it in workspace for now. So game.workspace.part. Now I'll show you some of the common basic properties and how to change them. We type a dot when we want to access a property, just like we would if we wanted to access a child. For now, we'll change the name property. You see right now, if we scroll down, the name is part. Maybe we want to change the name to eyes. But remember, it's a string, so we have to do the quotation marks around it, or whatever other method for strings. And nothing's happening right now because scripts only run when the game is played. So let's test it out. And now let's look at the Explore tab. Oh, it's called eyes. And in the property, it's also called eyes. We changed the name. You have to make sure you use the right data type for the right property. If you want to change, like, let's say name, you're like, I don't know if this is a Boolean or if it's a number. You can always just look at the actual properties window and, oh, this is text. I know that text is a string. So let me make sure I make it a string when I change it in the script. I like double quotes, but you can use whatever you want. We can change most properties. The ones we can't, like class name, are grayed out. This is a read-only property. But for now, let's only focus on the ones that we can change. The transparency property takes in a number 0 through 1, as I explained in the properties video. So obviously we can change this using a script and it'll take in a number. We can't make it transparency equal to eyes because look, if we try to do it, it stayed the same. Nothing happened. We can't make it equal to eyes because eyes isn't a number. It's not going to work. So let's change it to, I don't know, 0.75. Right now it's at 0.5. Change it to 0.75 transparency and there you go. We changed it using the script. The transparency property, we can do some cool things like make it go invisible, then wait a second, and then we'll change the transparency back to 0, and then wait a second, change it back to invisible, and it'll look like this. Visible, then invisible again. Pretty cool, huh? The last two properties I'll show you are Booleans. Let's make sure that the part is anchored real quick. And anchored is checked off, so it's equal to true. And first, we're gonna wait 10 seconds, and we're gonna change the parts can collide to false. Game.workspace.parts.canCollide equals false. And then we'll wait 3 seconds after that, and then we'll turn the anchored off. Game.workspace.parts.anchored equals false. So right now as it stands, the can collide is true and the anchored is true. But according to the script, we're going to wait 10 seconds and then we're going to change the can collide to false, and then we're going to wait 3 more seconds after that and make the anchored false. And if you see me using wait, it's okay, you can use either one, but task.wait is better. I'm just bad, okay? And let me join in with my character. So we're going to wait 10 seconds and then the can collide is going to be false. If I fell through it, and the anchor is going to turn false. So it's going to fall down. And remember I told you that if you print out any data type, like a Boolean or number, it'll transform it into a string. So you can print out the properties like this, so you can see what the value is equal to. The name is equal to part, the transparency to 0.5, the can collide is true, and the anchor is true. Sometimes we mess up, and sometimes the script lets us know. If we write, for example, part.transparency equals 0.5. You see how it underlines red? It doesn't know what part is. We didn't specify that it's the part inside a workspace inside a game. That's why it has the red line underneath. It doesn't know what part is. So if we run this, we get attempt to index with nil. If you recall from the Boolean video, we mentioned that nil is nothing. The script is basically saying that we didn't tell it what we wanted to affect since it doesn't know what part is. We can click on this red text and it'll take us to where the error happened in the script. So it took us right to this line. When you get an error, it's up to you to figure out what went wrong and how to fix it. We know that the script told us it's attempting to index nil. This tells us that the script doesn't know what part is because according to the script, we're trying to access nothing. And we know we're trying to access part. So there's a little miscommunication here. Hopefully this is enough to remind us that we have to specify. Oh, you don't know what part is? Let me be a little more specific. I messed up. That was on me. And we can specify game.workspace.part.transparency. If you get an error and you don't understand it, try walking through your code line by line. If you have a lot of lines of code, you don't have to go through everything, but just like the lines that you think will be affecting it. And then if you still can't figure it out, maybe then go through some more line. And also try to put your mind into the mind of the computer. Like before we had part, you can't just go straight to part. A computer wouldn't go straight to part. It would go to game, then workspace.part because it goes from broader to more specific. You have to try to get inside the mind of the computer. And also, you could try Googling your error. Not the whole thing, but maybe like attempt to index nil with transparency. And you don't got to tell it like what line, because what are the chances other people had the same line as you? But if you want, you can do it. But this is all that's necessary. If you try Googling that, I'm sure other people have had the same errors as you and have posted it online for you to find. Let me show you another example of another error. If we make a variable part equals game.workspace.part, you can assign variables to be equal to parts or any object in the game, not just values and stuff like that. So this is fine. But if I try to print the part's name and multiply it by 5, we're going to get an error. Workspace script 2, that's the script that the error happened in. Attempt to perform arithmetic on string and number. This just goes to show you that it's important to use the right data type. If you remember, a part's name is a string, it's text. You can't multiply text by a number, that doesn't make sense. So that's why it's telling us attempt to perform math on text. You can't do that. One more note I wanted to add real quick. We've always been writing game.workspace.part to access this part. We can just write workspace with a lowercase w, and it'll know, hey, it's game.workspace. That's just a little shortcut, so you don't have to write game.workspace every time. If you write workspace with a lowercase w, it'll work just the same, and I'll just print out part.name to show you that it still works just fine. So yeah, in the future, when you have to get something in workspace, just do it like this. It's easier if you want. Or if game makes more sense to you, that's fine too. Not all properties on Roblox take in the basic values like numbers, strings, and booleans like we've been going through. For example, color, it's not exactly a true or false, it's not a string or a number, it's its own kind of thing. See, this isn't really a number or anything like that, but we can still change it using the script, and I'll show you how to do that. We still have our part variable, so we don't have to write workspace.part every time, we can just write part instead, because we assigned part to be equal to that object. So now we can just write part.color to change the color equals, and it takes in a color 3 dot, and then you write dot new, and this is how we are able to change the color. And then you put in parentheses, and we're going to write 3 values. The first value is a number for how much red, the second one is going to be for how much green we want in the color, and then the last one is for blue. This color has 24 red, 46 green, and 70 blue. But when we write it in here, it takes in a value 0 to 1, similar to transparency. For transparency, 0 is not transparent at all, and 1 is 100% transparent. If we want it like 50% red, we would do 0.5, and it shows us a little preview of that color as it is right now. And to write the next value, we simply write a comma, and then we write how much green we want. And you can see it bolded up here to let you know that you're writing in the green number. Let's say, let's put a lot of green in there, and just a little bit of blue. And now we have this color. Actually, let's put some more blue in there. There we go. And that is one way to change the color. Even if it's not a basic data type like we showed you before, you can still easily change it. There are ways to change all these properties, unless they're read-only like this one, which are grayed out, which I told you before. But as I went over in our properties video, you can either change the color through the color or the brick color. And you can also just change the brick color instead of the color using a script too. To do this, you write part.brickColor equals brickColor.new, and then you write parentheses. And the difference is that instead of writing an RGB value with the 3 little values we just did, you write in a string. So I'm gonna do double quotes, and now you can see a list of all the built-in colors that Roblox has, and you can just pick one of those, or you can just write it out like artichoke. Let's see this part turn into artichoke. Okay, looks like the toothpaste color low-key a little bit. So the main takeaway of this video, even if it's not a basic data type like a number for transparency or a boolean for can collide, is still able to be changed with the script using some of these other methods. We went over how to change basic properties and even some fancier ones like the color you see right here, but some of them are a little bit weirder than that. Let's say we want to change the part's material. To do this, we're going to have to use something called enum. And when I was first learning, I was very scared of enums, but now I realize they're like actually super easy. Like I'm not just saying that, they really are. To change the property, hopefully by now you know, to access the part, we can just write part since we assigned it, and dot material since that's the property we want to change. And there isn't really like a material dot new that you can make. There isn't exactly anything like that. But to access the materials, we can just write enum dot material to access the list of values. So we write enum, and then what kind of enum are we trying to access? A material. We said we want to change the material here. We're going to pick a material. And then you press dot, And again, like with the color, you can see all the different options. Let's choose air. What is air? Oh, only it applies to terrain only. Let's pick something like brick or wood. Let's pick something like wood. Let me change the transparency to 0 and change it now. Now you see it has that wood texture material. That wood material. Looks nice. So whenever you have to deal with an enum, you always write enum and then the property you want to change, in this case material, and then the value you want to set it to. It's that easy. Enum, what you're changing it to. A simple way to do this is if you simply just write a string of the material that you want to change it to. And this does the same thing. You see? But it doesn't give you the little drop down menu. And I also wanted to show you how to do it in case you're forced to use an enum, because sometimes you have to use an enum, but they're really simple. Always when you're setting it, it's write an enum and then whatever property you would like to change, and then a dot, and then you write the value. That's how you do it. So both of these methods work the same way. I just want to show you how enums work, and also that method lets you see the drop down menu for the materials too. If you write a string, you just have to know the material you want. Scripts are very powerful and can create things. For example, if we want to create a new part, we can do that. All we have to do is write instance.new and parentheses. And this takes in 2 arguments. And arguments are just what you put inside the parentheses. Like when we print something and we type in hi, the hi is the argument. This instance thing takes in 2 of those. The first argument is a string, as it says up here, and that is the object that you want to create. In this case, we're just going to make a part. So type in part in a string. And to write the second argument, just write a comma. And this is going to be the parent of this new part. And as I've gone over before, you want to put it in workspace if you want it to be in the actual world. It is important that you give it a parent or else it won't have anywhere to be. Like if you didn't have your parents, you would have never existed. If the part doesn't have a parent, it's not going to exist. I'll show you. If I don't give it a parent, look what happens in the world. Nothing. And if we look inside the workspace, there's only one part which was already here from before. However, once we give it a parent, we tell it, hey, this is where you're going to live. You're going to be inside workspace. Now when we run it, wow, that's the part we created from the script. And you can see in the workspace, there are 2 parts now. The one from before and the one we just created. You can use this to instance just about any object. And you can see a list of them once you start typing. It's really neat. We'll stick with part for now. It's good practice to assign this new part to a variable so you can actually manipulate it and do stuff with it. So let's name it part B. So now whenever we reference part B, it'll be this part that we just created out of thin air that we will be referring to. If for some reason you really wanted to, you could leave the second argument blank and just make the part. And then whenever you're ready for it, like in 5 seconds, you can assign a parent to the part like this, part b.parent equals workspace, and then it'll pop into existence after 5 seconds or however long you want, or you don't even have to wait. You can just do it all instantaneously. Now we're waiting and bam, it pops out of existence. We can change whatever property we want on this part B. We can change the name to be equal to part B. We can change the color to be color3.new and make it completely white. We can change the material. It's as good as a part as any. It's a real working part and you can do whatever you want with it. But I'm not going to wait 5 seconds every time. Forget that. Ta-da! Well, that looks interesting. Speaking of changing parents, we could also change the script's parent. And I just want to show you that because instead of writing game.workspace.script to access this script we're working on right here, we don't even have to write workspace.script. We can just write all lowercase script and it'll know that it's talking about itself. And to prove that, I'll change the parent of it to lighting equals game.lighting. And it knows whenever you write script, it's talking about whatever script you're currently working on. So it's going to move itself into lighting. Watch the Explorer. Oh, the script isn't there. Let's see if it's in lighting. Oh, there it is. And it's the same script. So whenever you want to access the script itself, just write script in all lowercase. And you don't have to specify game.workspace or any of that. It knows it's itself. I just want to show you that. And it doesn't matter where the script is. You can put the script in put the script inside of base plate and it'll still move itself to lighting because it doesn't matter where its position is. It knows that it's referring to itself whenever you write lowercase script. Okie dokie, we're ready for another project. First thing I want you to do is instance apart. Then I want you to wait 3 seconds and then make the transparency to 25%. Then I want you to wait another 3 seconds and name the part to friend. And then I want you to wait another 3 seconds and I want you to make the part purple using whichever method you like, the color or the brick color. Then you know what, I'm just going to copy and paste this at this point. Wait 3 seconds. Then I want you to change the material to something pretty. And then I want you to wait 10 seconds actually. And why do I want you to wait 10 seconds this time? Because I want to give you enough time to cry. So because you won't be seeing your friend soon. Because the last thing I want you to do is set the can collide to false. So I want you to do all these things, pause the video and try it yourself, and I'll show you my solution to it. So if I were you working on this, I would use control slash so I could comment all this out single line, and then I already have my sections labeled and I know what I have to do. For example, in this part, I need an instance apart, new part, and we're just going to put that in workspace. And like I told you before, you always should make it into a variable. We can just name it part. That's a nice, easy thing to do. We're going to wait 3 seconds. And I'm going to be doing this a lot, so I'm just going to copy and paste this. And now next thing is to change the transparency to part. All you have to do is part.transparency equals 0.25 or 25%. Again, wait 3 seconds, task.wait. And then we're going to name the part friend. So part.name equals friend. And then 3 seconds. Now we're going to change the part's color to purple. So part.color. I don't really know what purple colors they have. Or I'm going to just use a brick color so I don't have to figure out the RGB value. I guess plum is fine. Let's make it brick color. Brick color.new plum. And wait 3 seconds. And now we're going to change the part's material to something pretty. Material equals enum.material. I don't know what's pretty. Concrete? Sure, why not? Now I'm going to wait 10 seconds so we can cry. And yes, you have to cry or else you fail the project. Then part can't collide. I'm going to set that equal to false. And that's all it takes, man. So the part gets made. Change the name to friend. Change the color. Change the material. There we go. I hope you cried. We've seen a variety of different values properties taken. Now I'm going to show you one of the most common ones. This is known as vector 3. Roblox by default is a 3D world. It has an x-axis going left to right, a y-axis going up and down. And if you've done anything with graphs before, it's the exact same thing. You know, you have your x-axis going left and right, and your y-axis going up and down. The only difference is there's a third axis, the z-axis, which goes forward and backwards. If we want to change a part size, we can do it in all 3 dimensions. Let me remove this part and add a new one. Show you that by default, the part size is 4 studs in the x-axis going this way, 1 stud in the y-axis going up and down, and 2 studs of depth going this way. If you know how big a stud is, each one of these little squares is 1 stud. They're 1 stud away each. So as you can see, it's about 1, 2, 3, 4 studs, and about, if we line it up, 2 studs this way, and yeah, 1 stud high. Let's say we want to use the script to change this part size. Instead of being 4 by 1 by 2 to be 20 by 1 by 2, I'll show you how to do that. Let's just assign part to be equal to workspace.part so we don't have to write workspace.part every time. Part.size equals vector 3, and then you write .new as we've been doing with some of the other properties like color, and then in parentheses, and this takes in 3 arguments as you see right here, 1 for the x-axis, 1 for the y, and 1 for the z. And we said we wanted this to be 20 by 1 by 2, so you just write 20 for the x-axis, 1 for the y-axis, and 2 for the z-axis. And now when we run this, bam, it gets elongated to 20 in the x-axis. Obviously, we can make these values whatever number we want. As long as it boils down to a number, we can make it to whatever. Let's make it into a 30 by 30 by 30, and this will be a giant cube. Whoa, look at that. And yeah, you can even do some cool stuff. If you set it to 15 by 15 by 15, then you wait, and then make it 20 by 20 by 20. Then you wait, you make it 25 by 25 by 25. You can get some cool effects just by messing around with some of the other features we already learned and including them with this new one. You can make it grow. Pretty cool. I'm going to change this part to green and I'm going to make a new part, change it to red. And I'm going to make this a random size. And I'm going to make this a random size. And this green part, I'm going to rename it to part A. And this part, I'm going to rename it to part B. And don't forget, now we're not accessing workspace.part anymore because that's not a thing. We're going to access workspace.part A. And we can name this to part A. We can name this to part B. Goes workspace.part B. So now we're accessing both of those parts with the variables. And let's assume we have part A here, but we want this to be the same size as this. You don't have to come in here and look and then copy and paste the size. You can just easily write part A dot size equals part B dot size. Because what kind of value is this that we want to change? It's a vector 3. And what kind of value is part B size? It's also a vector 3. So we can change the size to anything. As long as it's a vector 3, it'll work. I'll show you that. Let's run this. Bam, it got transformed into the same size. They're twinning and winning. I don't know what that means, but it sounded nice. Remember those grayed out properties I told you that you can read, but you can't really change? If you want to change the size in just one axis, you can't just do size.x and equal size.x because this can only be read. It cannot be assigned. But you can use it, but you cannot assign it. I'll show you what I mean. I want this green part's x value to be equal to this part's x value, but I want everything else to be the same. So one way we can do this is by setting it equal to vector3.new. We want part A's x value to be equal to part B's x value. So since we're changing part A's size, we're going to set the x value to be equal to part B dot size dot x value. And we want part A's y and z to stay the same. We can just put in the size dot y and the size dot z. This will make a new vector 3 that's made up of the part B's x-axis and both part A's y-axis and part A's y-axis. So the y and z-axis of this part size will stay the same, but the x will be copied from part B, and I'll show you what that looks like. Bam. So it's the same amount of length this way, but it still kept part A's original thickness and height. Position is very similar to size in the sense if we look at the size, it takes in 3 values, one for the x, y, and z. And if we look at the position, it's the same sort of ordeal, x, y, and z. If we look at the position, it's the same thing, x, y, and z. If we position a part to 0, 0, 0, that will take it to the center of the world, of the game. And part's position is based off the exact middle of the part. So that's saying that the middle of this part is located at 0, 0, 0. All the positions are based off of the middle. So if we change it, for example, the y-axis to 15, it'll move up from the origin 15 studs. If we move it to 25, 0, 0, that'll be 25 studs in the x-axis relative to the middle. And if we make it negative 25, it'll just move it in the other direction. Just like a graph, but with an added z direction. And obviously we can combine multiple axes, like we can make it 25, 15, 0, and it'll move 25 in the x and 15 in the y, and 0 in the z. Let's do all this using a script. So do our little shortcut part, and then to change the position, you write dot position, and it's a vector 3 like size. Dot new, because we're making a new position. Do it 25, 0, 0, and watch it move 25 studs in the x-axis. Ta-da! And negative 25 studs in the opposite direction. Ba-bam! And 25, 15. Oh, it fell down. It wasn't anchored, but it's okay. Its heart was in the right place. Let's anchor the part for now. And let's move it somewhere random, I don't know, over here. And let's say you want to move this part 10 studs up to where it is now. Not just to 0, 10, 0, because that'll move it 10 above the origin. But you want it to move it 10 above where it is right now. There are 2 ways to do this. I'll show you. Similar to how we did with the size, where we took the size.x, we can take the part's position.x and keep it the same because we just want to move it 10 above where it is right now. So the x and z will stay the same, but the y will be whatever it is now plus 10. So we can do this by doing part.position.x, lowercase part, comma, part.position.y, and then plus 10 because we want it to be 10 studs higher. And again, we want to keep the part.position dot z, because we want the z to stay the same. So let's look at that run. See, it's 10 higher than what it was before because the x and z stayed the same and the y went up by 10. Another method, which is probably the way I would go about doing it, is simply saying I want the part's position to be equal to whatever the part's position is now, but we're going to add an additional vector3.new of 0, 10, 0. So this is saying take the part's position and I want it to be the same exact thing. If we just had this part, the part wouldn't move because we're telling it, hey, I want your position to be equal to whatever your position is right now. So that's not going to change because the position is equal to what it is right now. But you can add a vector 3 to another vector 3 because remember, the position is a vector 3. So you can add in another vector 3 value. In this case, we want to move it up 10 studs in the y-axis, which is up. So that's why we add a vector3.new and we want it to move up 10 studs. Bam, it does the same exact thing. I think this method is just a little bit cleaner and easier to understand. And like if you wanted to change something, it's a lot easier. You just write like if you want it 15 in the z also, you just change it right there. See, it moved up and back. Again, let's name this part A, and we'll make a red part, name it part B, and assign the variables correctly, part B. And now let's say we want this green part to go 10 studs above this red part. Can you figure out how to do that using what we just learned? You want to set part A's position to be equal to part B's position. And then you're going to add a vector3.new 10 studs up. So it's going to move the green part to the red part's position and then up 10 studs. See, green part's position to the red part's position and then plus 10 studs in the y direction. Ta-da! And this will work no matter where the red part is. It's always going to go 10 studs above it. Rotation is pretty similar to position. It's a vector 3. Right here we have part A, and if you want to change part A's rotation, just write part A dot rotation, set it equal to a vector 3 just as you would with size and position. Dot new, and again, this is the value in degrees that you want to tilt it in the x-axis, the y-axis, and the z-axis. If you don't know what I mean, you can rotate it in the x-axis like this, the y-axis, and the z-axis. It is in degrees, so if you change it to 180 degrees in any axis, you won't notice the difference because 180 degrees is half a turn, so it's the equivalent of doing that. And that looks exactly the same as that, so you can't really tell the difference at all. Same if you do any multiple of 180, like 360, 720, it's all going to look the exact same because that's basically doing nothing. I mean, doing half a spin is something, but like doing this is essentially enough. It's in degrees. So if you want to turn it like quarter of the way, that would be 90 degrees. Oh man, I hit the wrong button. Ta-da! And if you want to do half of that, change it to 45 degrees. See? That's a little more than 45 degrees. Oh, I guess not. I'm going to randomly rotate this part. And if you want the green part to mimic this rotation exactly, it's exactly as you would do it for the position. So just set part A's rotation to be equal to part B's rotation. And bam, they are identically rotated. This is just some cool stuff that I thought I would mention since we're learning about vector 3s. I was just thinking about you guys, and comment down below. Thank you for thinking about me and showing me this cool stuff. The cool thing I want to show you is finding the distance between 2 points. We're going to use these 2 parts. Let's get rid of this rotation. I want to use these 2 parts to symbolize 2 points in space because points have a position and these have a position. Let's just position them randomly within space. I don't know, like that. And I want to show you how to find the distance between them. So this green part is part A and this red part is part B. Get used to that during the series. If you see a green part and a red part is going to be part A, red part is going to be part B. And oftentimes you don't need a part, you just need a position, but I like using parts to help you visualize where they actually are. And I want to make them into like a little cube. We'll make this into a 2x2x2. So these are 2 points in space. The way you get the distance, and I'll put this in a variable, between 2 points is just part B's position minus part A's position. And then we put that in parentheses and do dot magnitude. And I'm going to show you why this works first. That might be a little confusing in 3 dimensions, but I'll just show you in 1 dimension. Okay, so right here we have one dimension. Just think of this as the x-axis. Let's say part E is currently at position 2, and the part B's position is currently at position 8. So this has a position of 2 and this has a position of 8. What is the distance between them? What is this distance? Well, if you're smart, you can probably figure out that you can just count 1, 2, 3, 4, 5, 6, and the answer is 6. However, you could just do this position minus this position and get 6, which is basically what you're doing. Subtracting is also known as the difference because you want to know how different these are, aka how different their position is. It's 6 units difference because they're 6 spaces away. You do this by subtracting part B's position from part A. You could also do part A's position minus part B and then take the absolute value of that, because 2 minus 8 would be -6. And the units is still right, but it's just the wrong direction. But it's fine. The number is what we care about, the actual distance. And then we write dot magnitude. I'm not going to get into vector math right now, but we want a number. I'll just say that we want a number, and dot magnitude lets us get that number. So let's print out this distance and see how far away these two are. Comment down below your guess. I'm gonna guess 35 studs. I was way off. It's 21. Yikes. Cut that out. Just kidding. I'm the editor. But yeah, this magnitude is just a property of vector 3. Like one of those read-only properties like the size.x or stuff like that. We can read it, we can print it out, but we cannot set this equal to something. An if statement is just a condition that we decide, and if that certain condition is true, code will run. We choose the condition and we choose what happens when it runs. I'll show you the syntax for it. Let's write all lowercase if 1 plus 1 and then 2 equals sign 2, then print hi. I'm assuming you guys know how to print by now. You put in a string and stuff. Yeah. The syntax for an if statement is you start it off with the word if and then the condition that you want to check if it's true or not. In this case, it's 1 plus 1 is equal to 2. And when you're scripting, the single equals is used for when you're making a variable. Like if you have this, that's when you use a single equals to assign this variable to equal to that. When you want to check if a condition is true, you use 2 equal sign. Like here we're checking, does 1 plus 1 equal 2? If that's true, then you can print hi. Everything we put in between the then and the end is going to happen. We could have hundreds of lines here, and this will all be printed out if the condition is true. You see how it's printed out? Because 1 plus 1 is indeed equal to 2. What if we change it to 1 plus 1 is equal to 4? In case you don't believe me, nothing happens because 1 plus 1 is not equal to 4. I'm not a liar. It doesn't just have to be a mathematical equation. It could be any sort of condition. And what I mean by that is like maybe you want to check if a part's name is equal to something, like if workspace.part_a.name is equal to part A, then print this stuff. Is part A's name equal to part A? It is. So it prints out I know. We could even check any property we want. We could check if the transparency is equal to like, I don't know, 0.5. It could be, we can check if the transparency is equal to anything. 2 equal sign, remember. And then if it's true, we can say print it is true. But too bad that the transparency is not equal to 0.5, so nothing gets printed. Yeah, you can check any property, check if it's equal to whatever you want. And like, what if you're not sure if this condition is equal to true? Well, you can even print out conditions like this. And this is going to check, is workspace.partA.transparency equal to 0.5? And if it's not equal to 0.5, it'll print out false. But what if the condition is true? If the transparency is equal to 0, now checking if the transparency is equal to 0, and that is indeed true. Basically, conditions boil down to true or false. Anything that boils down to a Boolean can be used as a condition. In fact, we could even just write true here because that is a Boolean. Anything that boils down to a Boolean will work. If true, then yeah, anything that boils down to true will cause the code to run, even if it's just true. And anything that boils down to false will not run, even if it's just the word false. But that's kind of useless since true is always true and false is always false, so like there's no need to check anything. Something I want to cover, you might have noticed this little drop down menu thing, this little drop down triangle thing. This means that this is a block, and what that entails is that you have a start and an end to it, and the end is always going to be end. So from the if statement to the end, this is all a block. That means everything in here should be indented. No matter how many things you have, it should be indented. You shouldn't be writing stuff over here. That's not good practice. everything within a block should be indented. Something else about a block is that if you make a variable and add the word local to it, for example, local var equals 21, then it's only going to work inside of that block. For example, if we take this local var equals 21 and put it inside of this if statement block, and then we try to print it outside of it, you see that error message we got underneath it? Because it doesn't know what it is. If we get rid of this local, it does know what it is. But since we wrote it local, this variable only exists within this block. However, if we were to declare it outside of this block, you see how these are all in the same script block? I guess you can consider everything outside its own block. Then I can still print it just fine because it's in the outer block. It's in the outermost block where everything is inside of. So when it's inside of here, it can only be used within the same block. You see, this is fine. But if we use it outside, then we can use it anywhere within the whole script. So why does anyone use local in front of variables if it just is more limiting? Well, the first thing is that it's often bad practice to declare a variable inside a block and then try to use it outside of that block. That's not good practice because it makes things wonky and things might not work out the way you want. And second, it's better optimized since the script doesn't have to worry about as many variables. Like, it doesn't have to worry about, oh, what if you call a variable outside of here? No, it only has to worry about this variable in these few lines of code. It doesn't have to worry about that variable in all the others of lines of code you may or may not have. So it's better optimized this way. And that's why you see most variables are local when like the vast majority of the time. So we did the if statements, but what if you want to do something else when the condition is false? Well, that's when we use an else statement. To use an else statement, you have to make an if statement. For example, let's use this part and make a variable local part A is equal to workspace.partA. And we want to check if this part's transparency is equal to 1. And if that part's transparency is equal to 1, we're going to print howdy part. Now we're going to add an else and we're going to print oi mate. So what the script is doing is if part A's transparency is equal to 1, it's going to check, is the transparency equal to 1? No, it's not. So if it's equal to anything else but 1, then it's going to print oi mate. So take a guess, what's it going to print out here? It printed out oi mate because it took a look at the transparency. Is it equal to 1? Nope. Well, if it's not equal to 1, do whatever else is in this section. But what if we do change the transparency to 1? What's going to happen now? Howdy partner. So what the script is doing is if the part's transparency is equal to 1, it's going to check, oh, it is. So he's got to print this, and it doesn't even worry about the rest of the code. It just does one condition. Let's say we want to print howdy partner if the transparency is 1, and we want to print oi mate if the transparency is equal to 0.5. And if it's neither of those, we want to say goodbye. See you later. We can use an else if statement for situations like this. Let's make the if statement like normal, the first condition, and the second condition, we're going to use an else if. It's just the same as an if statement, but inside of this if statement, if that makes sense. Else if the part A dot transparency is equal to 0.5, then, so it's going to check, is part A's transparency 1? Oh, it is. So now we're going to print howdy partner. And that's it. It doesn't check any more of the else if statements or the else. But let's change this to 0.5. Now it's going to check, is part A's transparency equal to 1? Nope. Moving on to the next else if statement. Is it equal to 0.5? It is. So it's going to print oi mate. But if it's none of those, we want to print out else. We want to print goodbye, see you later. And the if, the else if, and the else are kind of like their own little block, kind of. And that's why they're off to the side. They're not indented, but they're part of this guy. They're just like subsections within the if statement. So they don't get indented. They go all the way at the same level of this because they're all at the same level. So as you can see, it's going to check, is it equal to 1? And if it is, it'll print this. If it's not, it'll move on to the next condition. Is it equal to that? If it is, it'll print this. If it's not, it'll go to else. And this else, it doesn't matter if it's 0.75, it doesn't matter if it's 0.05. It's going to print this out no matter what it is. If it's not equal to any of these prior conditions, it's going to print out whatever we told it to in the else statement. This is like a catch all other scenarios type of thing. And yeah, you can do as many else if statements as you'd like. Else if part A dot transparency is equal to whatever, then else if part A dot size is equal to vector3 dot new, whatever. You can do as many else if statements as you'd like, but 2 equal signs. I'm a terrible teacher. But let's keep it to how we had before. Little quiz time. I'm gonna change this to 0.5. Tell me what's gonna happen. Wait, mate. Change it to 0.6. What's gonna happen? Goodbye. See you later. I'm gonna change it to 1. Tell me what happens. Howdy, partner. Alright, time for our third project. This is what I want you to do. I want you to add an anchored part. So add a part and then make it anchored. Then I want you to wait 3 seconds. I like waiting 3 seconds, I know. I want you to make the part 3 times as big as it is. Next, I want you to move it to 0 in the X, 25 in the Y, and 0 in the Z. And then finally, I want you to rotate it 45 degrees on the Z-axis. And this is the first project. This is the first project I want you to do this video. Pause it now and try to do it on your own. And I'll go through my solutions after. So again, Control/ to comment it out by line. And the first thing we're going to do, add an anchored part. And we can do this local part equals instance.new part in strings. And then we want it in workspace, of course. What's next? We task.wait 3 seconds. We're going to make the part 3 times as big as it is. So part.size equal, we want it to be the same size, but 3 times bigger. So part.size, and then we just multiply it by 3. And this will multiply it by 3 in the x-axis, the y-axis, and the z-axis. You can just multiply it by 3. It's pretty neat. We want it to move it to the location of 0, 25, 0. We'll do that part.position equals vector3.new 0, 25, 0. And rotate it 45 degrees in the z-axis. That's just part.rotation equals vector3.new 0, 45, 0. And you could space this out a little bit just to make it look nicer. Look how nice that looks. Don't forget, we want an anchored part. So part.anchored equals true. My bad. So we add a part that's anchored, and then we move it up, rotate it 45 degrees, and made it 3 times bigger. The second project, first thing I want you to do is make a variable called channel awesomeness and set this equal to a percent. Well, not really a percent, just the number from 0 to 100. This channel is really awesome. Make it 100% awesome. So just write 100, set equal to 100. Maybe it's like 50%, just write 50. I don't know, whatever you decide. And then make an if statement that checks if the variable is equal to 100. And if it is, then print a. Make another statement using Elseif that checks if the variable is equal to 99. And if it is, then print things are going downhill. And if it's anything but 100 or 99, then print yikes. And then it also prints, give me some feedback on what I can do better. So pause the video now and then I'll show you my solution for this. So make a local variable, channel awesomeness, obviously 100%, right? And we want the first if statement, if channel awesomeness is equal to 100, then print a. Let me just move this end down here since we're going to be still doing stuff here. Then else if channel awesomeness is equal to 99, then print things are going downhill. Else, if it's not 100 or 99, print yikes. And then print, give me some feedback on what I can do better. Let me just make this a little cleaner by spacing it out a little bit more. You can do this, it won't affect the script at all. Just make everything nice and fit, aligned together. Still a little messy, but it's okay. So the channel awesomeness is at 100 right now. Should print out a. What if I make it equal to 99? Things are going downhill. Yeah, tell me about it. Now let's make it 101. Yeah, you guys thought I meant this. If it was bad, if it's anything higher than 100, I still want some feedback. Okay. Yikes. Give me some feedback on what I can do better. For starters, let's print out this condition. 1 plus 1 is equal to 2. So we're checking if 1 plus 1 is equal to 2. That, of course, is true. It boils down to true. But what if we wanted to check if 1 plus 1 is not equal to 2? Instead of typing equals equals, we can type in this little squiggly, and this checks if 1 plus 1 is not equal to 2. And that boils down to false, because is 1 plus 1 not equal to 2? No. What? I'll show you with like if we use 3. 1 plus 1 is not equal to 3. So this statement is true because it's checking 1 plus 1 not equal to 3. True, it's not equal to 3. True. We can use this for other data types as well, not just numbers. Let's add in a part. We add in another part and make it into part A and part B. Part A and part B. We can check if part A's position is equal to part B's position. Does it look like their positions are exactly the same? Probably not, but let's check. False. So it's not. But are they different? Are they not equal to each other? True, they are not equal to each other. So yeah, you can use this with like numbers, vector 3s, booleans, strings, whatever you want. But let's go back to numbers. We can also use the less than or greater than symbols to see if this is greater than this or this is less than this. For example, this is saying, is 1 plus 1 greater than 4? Let's go back to the other project to show you. I'll get rid of these comments to make everything easier to learn from. Instead of checking if the channel awesomeness is equal to 100, we can check if it's greater than 90. And then if it is, we can print, let's go. And we can also check else if it's less than 10, I can print, oh, I had a typo, oh no. We can print, sorry for being trash and putting out trash content. And if it's anything else, it's not higher than 90, but it's not less than 10, you know what? Print out, all right. Well, let's just test this out. Let's get 95, 90, let's see. Let's go, because 95 is greater than 90. What if we print out, oof, someone gave me a negative 23. What does it print out? I'm sorry for being trash, yeah, because it checks. Is negative 23 bigger than 90? It's not. So what's the next statement? Is negative 23 less than 10? Yeah, it is. So I'm sorry for being trash. And if it's anything else, something in between 90 and 10, like 75, 75 is alright. It's alright. This is a great example of why it's important to remember that scripts go in order. If we make this first statement, check if it's greater than 80, and then we use this second statement to see if it's greater than 90. What do you think the score will be when I make it equal to 91? This statement checks to see if it's greater than 80, and then this statement checks if it's greater than 90. So what do you think will happen when it's equal to 91? Prints out, let's go. Because remember, scripts go in order, and as soon as one of the conditions is met, it doesn't go on to check any of the other conditions. Is 91 greater than 80? Yes. So it's going to print out this condition, and it's done. It's not going to look at this next condition at all. So yeah, it's true for, even though it's true for this statement too, it already checked it was true for this one and it did it and it's done. It only does one of the statements. It doesn't do multiple. It does the first one that's true and then all of the other statements are ignored. Let's go back to how we had it before. What if we change it to 90? 90 is still alright because it only checks if it's greater than 90 and 90 is not greater than 90. If we want to check if it's equal to or greater than, we can just write an equal sign. And this will check, is 90 equal to or greater than 90? And it is equal to or greater than 90 because it is equal to 90. So it prints out, let's go. And you can do the same thing for the less than or equal to 10. If we change this to 10, I'm sorry for putting out trash content. The last video we looked at comparing things using the squiggly line to see if they're not equal to each other. Like this, 1 plus 1 is not equal to 4. That is true, they're not equal to each other. But another way we could sort of do the same thing is by using the not keyword. I'll show you an example. If we want to print workspace.part A and check if the anchored is equal to true, the anchored is equal to false. But what if we want to check the opposite? You could just do the squiggly line here and see if it's not equal to it. True, because it's not equal to false. So this statement is true. But another way to do this is if you just write the word not in front. But you have to put this condition in parentheses. And what is this doing? Since we put this in parentheses, it's checking this statement first. Is workspace.part.anchored equal to true? No, so this is basically false. And this not just gives us the opposite of whatever condition is next to it. So the opposite of false is true. So it's going to print out true. Yeah, and it can get really convoluted. Like if you have a lot of double, triple negatives, like is workspace.part A not equal to false? And then you want not in front of it. Like, oh, is it equal to the opposite of the opposite? Like it gets confusing. But just know that whenever you see not, it does the opposite of what it is. Like not true is false. Not false is true. We could even check multiple conditions on the same line. Let's say we have two variables, one for channel, we'll set that equal to eyes, and one for score. We'll set that equal to 100. We want to check two things. One, if the channel is eyes, and two, if the score is higher than 90. We can do that all in the same line by doing a simple if statement. If channel is equal to eyes, so now I know which channel they're talking about, and the score is higher than 90, then we can print out, I'd like to thank God for this award. And it doesn't have to just be related to this. It could be anything. You could be like, and workspace dot baseplate dot color is equal to a certain color with 2 equal signs. You can check as many things as you'd like and just keep putting and to make sure you have that and keyword, and it'll check that both this statement is true and this statement is true. They both have to be true. Let's just see if this works as is. Bam, it works. Because both channel is equal to eyes and score is greater than 90. But what if the score wasn't greater than 90? What if it was 80? Would this still work? No, it doesn't print out anything. Because although this part is true, this part is not, and they both have to be true. That's what and means. Both sides have to be true. It's like when you go to the store and your mom is like, get me some eggs and cheese and yogurt. And then you have to get eggs, cheese, and yogurt. Even if you just get the cheese and yogurt and you didn't get the eggs, it's not enough. You need to have everything. If your mom asked for this and that and this, do better next time. However, if you only care about one of the statements being true, you could do an or. It just checks this one or this one have to be true. They don't both have to be true. So what would happen in this scenario? It prints it out. It works. Because although this part's not true, it doesn't matter. This part is true. Only one of them have to be true. But if none of them are true, it's not going to work. At least one of them has to be true. Yeah, they can both be true too. That works too. As long as one of them is right, they both work. It's like when you go to the store and your mom is like, get me either cheese or eggs or yogurt. And you show up with just the eggs, it's fine because she only wanted one of the three. Or even if you show up with the eggs, cheese, and yogurt, it's still fine because she said or. If you have multiple things like, and then you have an and, 1 is equal to 1, and you have multiple things, it normally goes in order from left to right. But this could cause issues, so you can also use parentheses in your conditional statements. I'll show you an example of when this is useful. Alright, so we have this condition right here, and you don't need to understand this right now. I'll go over it with you, but just know if it boils down to true, it'll print out option A, and if it boils down to false, it'll print out option B. So let's see what it prints. Option A. And why is that? It goes from left to right. So false and false. Remember, they both have to be true or else the whole thing is false. And right here, neither of them are true, so it's going to be false. Then it checks out false or false. And for or, only one of them has to be true. But in this case, neither of them are true, so it's going to be false. And then false or true, I just said one of them had to be true and one of them is true. So it's going to boil down to true, and that's why we got option A. However, just a few simple parentheses around this last section. Let's see what happens now. It prints out the other option. And why is that? Because now it's doing what's in the parentheses first, just like in math. Let's go over it. False or false, it's going to be false because neither of them are true. False or true, that's going to be true. And that's all that was in the parentheses. And then false and true, for and, they both have to be true, and they're not both true, so it's going to be false. And that's why you got option B. And you can see why parentheses are important to make sure it behaves the way you expect it to. Loops let you run part of your code multiple times. For example, we could just write print subscribe, and we can copy and paste this over and over and over and over and over again. And then we run it. You see it does it, whatever we tell it to, over and over and over and over again. However, we could just use a loop and the loop will do this over and over for us. First loop I want to go over is the repeat until loop. This loop will repeat something until a certain condition is met. Let's get rid of this other part and we'll just name this part. And let's say we want to increase the height of the part until its size in the y is equal or greater than 30. So the syntax for this kind of loop, you just write repeat, and when you hit enter, the until will appear. So whatever you write in between the repeat and the until will be repeated until the condition is met. I'll show you what I mean. We can say workspace.part.size. We want it to be equal to the same size, but we want it to grow in the y-axis by 5 studs every time. And let's just do a wait 1 second so you can see it happen. And how long do we want to do this for? We want to do it until the workspace.part.size in the y direction is greater than or equal to 30 studs tall. And let's see this happen. See, it keeps growing, 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 and then it stopped growing because the size in the y direction is finally bigger than 30. And you don't need to have this rate right here. I just wanted to show you increments. If you don't have it, it'll just loop it all instantly. So everything we put after the repeat and before the until will be repeated until this condition is met. That's why this condition is just one line, so you don't have an end like you would with a if statement block. But let's say we want to keep it going until the part's height is this number, and we want to increase the part's height by 5 until it reaches this height. And we don't have any weights. We want it to do it now. So let's see what will happen. Oh no. Roblox Studio just crashed. Hopefully you didn't follow along with me. You see script timeout, exhaust allowed, execution time, blah, blah, blah. Back in my day, Roblox Studio would just crash your computer, but now you get an error. That's why it's important to have weights. If you don't have a weight, it'll try to loop this instantly until it gets to this number, and that is ridiculous. Your computer can't handle that. That is what happens when you don't have a weight and you have a condition that won't be met soon or will never be met. For example, if we do like until 1 plus 1 is equal to 3, 1 plus 1 is never going to be equal to 3. So it's just going to keep going and going and going forever. Look at this go. Look at this. Look at this. Well, it's going to stop now, but 1 plus 1 is still not equal to 3. We can also do the same exact thing while using a while loop. This is a more common sort of loop, and it works sort of similarly to the one we just did. The syntax for this is you write while, and then you write the condition. So it's going to be a little different. While the part's size in the y is less than 30, and it's the opposite because while this condition is true, it's going to keep looping. And the other one was we're going to keep looping until this condition is met. So you see how they're different? And this is almost exactly like an if statement, except that instead of doing what's inside of here one time, it'll loop it until the condition is false. So I prefer this method over the repeat loop, and it's a lot more common. So again, let's just try to do the same thing. We're going to wait a second, and then we're going to make the part's size equal to whatever the part's current size is, and we're going to make it grow 5 studs in the y-axis. And as you can see, it's doing the same exact thing as before, but we just scripted it in a different way. So what this does is checks, is this true? Yup. Then I'm going to wait a second. I'm going to make it grow. Then I'm going to check, is this true? Yup. Okay, then I'm going to wait a second. And then it keeps starting over. And then one day, oh, is this true? No, it's not true. Okay, so it just moves on from there. Again, remember to make this condition something seemingly possible. Like if you make it outrageous and then you don't have this weight, the same thing, it's going to crash. It's not good, okay? Remember to put the weight or make a condition that will end like in a reasonable amount of time. But just put a weight, better safe than sorry if you don't know what your computer can handle. See, the same error. So how do you know when to use a repeat, until, and a while loop? As you can see, we can use them pretty much interchangeably. The main difference is that the while loop checks this condition and then runs the code, while the repeat until loop does the code that you want to loop, and then it checks the condition. So that's the main difference. It's really up to you, but I think this looks nicer, and I'm more used to while loops. I like while loops. So it's up to you to pick the right one based on the right situation. For this project, I want you to make a local variable. Just assume that every variable, you're going to write local in front of it unless I say otherwise. Make a variable called test score and set it equal to 0 for now. And then I want to check if it's greater than 100 or less than 0, then print I'm not grading this. Nice try, cheater. However, if it's greater than 90, then print amazing. You could have only gotten this far with such a good teacher like myself. If they get anything 90 or lower, print if you get a good score, that's because of me. If you get bad score, it's because of you. I take no responsibility. And this is the first project. There will be another one in this video, so pause it now and try to do it on your own, and I'll show you my solution. So make a variable called test score equal to 0. If test score is greater than 100 or less than 0, those aren't realistic. Whoops. Or test score is less than 0. So we're going to print, I'm not grading this, nice try cheater, but I'm just going to copy and paste it. We'll move the end down there because we still have some more if statement stuff. Else, if the test score is higher than 90, then print amazing. You could have only gotten this far with a teacher, like with a good teacher like myself. I'm gonna take all the credit, all the credit. else print. If you get a good score, that's because of me. If you get a bad score, it's because of you. I'm not taking any responsibility, okay? It's not my fault you got a bad test score. So let's see. If they try to change their grade to 110, I'm not grading this. Nice try, cheater. What if they did 96? Amazing. They got that because of me. You're welcome. What if they just get a regular old 6? Yeah, that's on them if they get a regular old 6. Not because I'm a terrible teacher or anything like that. Second project time. I want you to make a script that prints this YouTube channel is amazing over and over and over again until it's stuck in your brain, until the parts transparency is set to 1. Just add a part in workspace and check continuously until its transparency is equal to 1. So it should repeat your YouTube channel is amazing until the parts transparency is equal to 1 over and over again. Pause it now and then I'll show you my solution to it. Okay, so I don't really need this. It's just one thing. I'll just remember it. I like using a while loop, but I kind of worded it in a repeat until loop kind of way. But while workspace.parts.transparency is not equal to 1, do print this YouTube channel is amazing. And hopefully, you remember to wait. Doesn't matter how much you wait, the lower the better, because the lower you do it, the more times it says that this YouTube channel is amazing. But if you do 1, that's fine, or anything. And now let's run it. And it's going to keep printing it over. You see the times 3, times 4. It's going to keep doing this until the transparency of this part is equal to 1. You see, now we set the transparency equal to 1 and it stopped. And it's not going to keep checking forever. Once it stops, it's done. Even if we change it back down to anything else, it's still done. The while loop is done. The script has moved on to bigger, better things. Well, this is the end of the beginner section, and you are halfway through this series. And I just want to say that you're amazing for watching this. And if you have any suggestions on any other video I should make, or any other suggestions of things you would like to see, I love all things Roblox game development, so I'd really appreciate any and all suggestions that you may have. And thanks for sticking through this series. The loops we looked at before, the while loop and the repeat until loops, they're great for when you want to repeat something until a condition is met or while a condition is met. However, if you want to repeat something a certain number of times, for that we can use a for loop. Let me show you the syntax for that. First, start off with writing for, then you write I equals, and now there's going to be two numbers, a starting point and an ending point. Let's do 0, 10 for now, and then you write do, and when you press enter, the end will appear. Anything we write in between the for line and the end line will be repeated. So whatever we do inside the for loop, it's gonna start counting at 0 all the way up to 10. So from 0 to 10, that's 11, because 1 to 10 is 10, 0 to 10 is 11. So let's go ahead and run that, and you can see it prints out something 11 times. That's basically how a for loop works. You want to start somewhere, like start at 1 and go up to 25. The first number is the starting point. The second number is the ending point. So from 1 to 25, there are 25 numbers, so it'll do this 25 times. Something useful you can do with for loop is using this I right here. It doesn't have to be I, it could be any. For example, it could be a count, like you can be whatever variable you want. And then we can actually print that number or use it in any other calculation. I'll just print it for now. And you see, it goes from the starting point at 1 and it goes all the way up to 25, the ending point. And yeah, we could even like wait half a second. The count is going to be equal to 1 because that's the starting point. It's going to wait half a second, print out 1, and then go to the end. Oh, we have to restart because we're not at the 25 yet. So now count is equal to 2. It's going to wait half a second, print 2 because it's equal to 2. It's going to go back to the start. Count is equal to 3, and so on until it gets to that ending point, which is 25. You see it waiting and printing. It's really simple stuff. And it'll keep printing all the way until it reaches to 25. Like I said, this could be anything. I just like having an I, and that's probably the standard thing you'll see. So let's just keep it like that. Remember in the other loops I told you that if it's a big number, you need to add the weight. Yeah, same thing for here. If you want to print trillions of stuff at an instant, your computer's not going to be able to handle that. So it's going to crash. So make sure to keep that weight if you have an unreasonably large number. Apparently, the for loop just crashes you. The error message didn't come to save me. I don't know. I didn't know that was a thing. But anyways, let's go back to what we were doing. Let's go back to printing the I value. And something else you can do is if you add a comma and a third number, you can change the increment to whatever you want. For example, if you make it equal to 2, it'll start at 1 and count by 2s. You see, 1, plus 2 is 3, plus 2 is 5, plus 2 is 7. And yeah, you can change this to whatever you want. We can make it count by 5s, 1, 6, 11, 16, 21. And notice it stops at 21 because if it were to loop again, adding 5 to this would be 26, and that's higher than the 25. So it's not going to go over this max number. You can even make this into a decimal. And it'll go like 1, 1.5, 2, 2.5. See? 1, 1.5, 2, 2.5. It'll count up by half to get to 25. However, if we make this too big, like I want to start at 1, go up to 25, but I want you to count by 50. It's only going to print it one time. Because the first time it starts off at the starting value, okay, that's fine. But the second time you add 50 to it, 50 plus 1 is higher than the ending point, so it's not going to print it. If you increment by a negative number, that's just not even going to work at all because you'll never get to 25 by adding a negative number to 1. But what you can do is start at a higher number and then go to a lower number. In this case, well, actually you have to use a negative number because how else will you get from a 100 to 0 without using a negative number? 100, 95, 90, see? Something you can do with loops is end it prematurely. For example, if you want to stop this loop from looping whenever, I don't know, base plate transparency is equal to 0, we can write an if statement. If workspace.baseplate.transparency is equal to 0, then the way we end the loop early is break. And basically break looks whatever loop it's inside of. In this case, it's all encased in this for loop. Even the if statement is encased in it. Then it will stop the for loop early, no matter if the I value has reached its end goal or not. It'll stop it, and then the script will move on with whatever else is going on later in the script. So what it's going to do is going to start at 1. It's going to set the I to 100, going to wait a second and print it, and it's going to check, hey, is the base plate transparency equal to 0? And then if it's not, it'll just keep going again and loop it, this time subtracting 5, wait a second, print it, and it's going to check again. Every time it loops, it's going to check it again because we put this if statement inside the loop. So anything we put inside the loop will happen every iteration or every time the loop is looped. And I'll show you that in action. As you can see, it's working fine because the base plate's transparency is equal to 0.5, so it's going to be looping just fine until the transparency is equal to 0. And you see, it printed the 40, then it checked the base plate's transparency. Oh, the base plate's transparency is equal to 0. And we told it if the workspace transparency is equal to 0, then break out of that loop. And now it's broken out of that loop. And even if we change it back, the loop is done. It's over. Forget about it. It already broke out. It's moving on to the rest of the script, onto bigger, better things. Methods are functions that let you do something that are built into an object. That sounds like gibberish if you don't know anything about what I'm saying, but let me explain. You know how objects like parts and any other object like script, anything, any object, they have properties built into them that changes the part's behavior or appearance. They also have methods that are a part of them, and these methods do things, and that sounds very vague, so let me show you an example of what I mean. Every instance or every object in Roblox has a destroy method. And let me show you a script that waits 5 seconds and then destroys a part. So wait 5 and then workspace.part destroy. So as I said, this script is going to wait 5 seconds and then poof, the part is destroyed. It's not transparent or anything, it's just completely gone from workspace and it's not anywhere else, it's just gone. So the syntax for using the destroy method is you write the object you want to access, then you write a colon, and then you write the method. In this case, destroy with the capital D and parentheses. All methods have parentheses. And once you write the colon, you get a list of all the methods. The thing about methods is that self is their first argument. That's not really important if you don't know what that means, but if you do, yeah, you already know then. I don't know why I said it. Another method you can use to any instance in Roblox is clone. So if we replace destroy, now we're cloning it. Similar to destroy, but we clone it. If you remember when we instanced a part, we had to give it a parent, and it's the same thing for the clone. So let's just name this local part equals workspace.clone. And if we run this, nothing will happen because we didn't give it a parent. So we do that by part.parent equals workspace. Make sure to assign your clones a variable so you can give them a parent later on. And now, after we wait 5 seconds, look in the workspace or look here, and the part appears. Ta-da, now we have 2 parts because we just cloned it. The same properties, same colors and everything. It keeps the same stuff. Both of these methods I just showed you are inherited from instance. And this basically just means that you can do it to any object in Roblox. Let's look at a method that only works on base parts. We're going to mess with the part we already have. Let's do apply impulse. And this takes in a vector 3. We covered that before. And let's give it an impulse of 100 in the y direction after 5 seconds and see what happens. That was so underwhelming. Let's give it a little more. Let's give it like 4,000. This just applies a force in the given direction, and we did the y, so it's going to be upwards. Oh yeah, there we go. That's what I'm talking about. You guys still see that? Yeah, let's go. So yeah, these methods are really cool. They do a variety of things. There is also like is a to check if this is a player or if it's a base part, which it is. And you can use this as a condition, like if workspace is a base part, then print life makes sense. Oh, I have to wait 5 seconds, but I'll cut this out for you guys, don't worry. Or maybe I won't. Life makes sense because it is indeed a base part. It returns true. But if we check if it's like, I don't know, literally anything else, pretty much. Like if it is a player, part is not a player, it's very loyal, so it's gonna not print anything. As we looked at in the last video, methods are functions that are attached to objects, but we can also make regular functions that aren't attached to anything. But what in the world even is a function? A function can basically be described as a group of instructions. First, we have to define the instructions, and this is like a blueprint. We're just telling the function what it does, and then we call it. That's like actually making the building. I'll show you how to define a function first. To define a function, we can just write function, and then write the name of the function. In this case, we can name it fun. Short for function, not fun. You're not having fun here, we're learning. And then you follow by two parentheses, and then we press enter to end the block. The name can be whatever you want. I just named it fun, but it should be in camel case, like variable names. And speaking of variables, you can also make it local, and this works the same way as a local variable. You can only use it in the same block that it's in. You can't use it outside of that block. Let's change this function's name to change the part, in which the function changes some properties of the part. Let's make it change some properties like workspace.part.color equals color3.new, I don't know, 0.24, 0.77, 0.12. That is very green. Let's make it 0.92. Actually, no. Let's make it 0.65 red. Okay, that's more interesting. Make workspace.part.transparency equal to 0.1. Let's make workspace.name equal to you just got changed. And now, when we run this, nothing happens. Because remember how I told you this is just like the blueprint. Nothing's actually built when you make a blueprint. This is just telling it, hey, when we call this, this is what I want you to do. But we haven't called it yet. So to call it, you just have to write the name of it. And the name is right here. If you forgot, it's in this fancy little yellow color. So now we actually called it. Whoops, workspace.part.name. And let's see if it happens. And now look, it works. It changed the color. It changed the transparency. It's barely noticeable. Oh, I see it. And it changed the name to you just got changed. And then you can call this as many times as you want. You can call it whenever you want. You can put in a loop and call it, if statement and call it. But in this particular case, it's not going to change much because after we set the color and transparency and name to that, it's already going to be set to that even if we call it again. So it's not really doing much. These parentheses are just for fun. I think the easiest way to explain this is to show you an example. If I make a function called print this with an x inside the parentheses, we can then later make the x whatever we want. For example, if I hit print x, and now when I call the function print this, instead of putting x, we can type subscribe. And I'll show you what happens when I do this. Subscribe. It prints out subscribe. The reason this is called a parameter, and the reason we put this is like a placeholder when we don't know what is going to be printed. We want to decide what's printed when we call it. When we're defining the function, we don't know what x is going to be yet. It could be anything. So it's just a little placeholder for now. And then when we finally get around to calling the function, we can write whatever we want in here. It's basically as if the x gets replaced with whatever we write in here. And we could use this in our previous example by writing part in here and changing all this to part. For example, let's assume we have many parts in here. Let's say we have part A, part B, and part C in here. We don't know which part we want to change while we're writing this, but then once we call it, we want to change workspace.part B. Part B has it coming. So when we call it, we specify, hey, we want to call part B, and this basically just replaces this with workspace.part B, if that makes sense. So now when we run it, bam, it changes part B. The benefit of doing this is before, how we had it, workspace.part. What if we wanted to change a different part? We have to change it here and here and here. But with the new method like this, we only have to change it one time when we call it. And now instead of changing part B, it's going to change part C. See that? See that. You could also have more than one parameter. For example, if we have x and y, and we want a function that adds those two numbers that we put into it, we can print x plus y. We don't know what x plus y are going to be, so we're just going to have that as placeholders. And then when we call it, we decide, maybe I want to add 21 and I want to add 17 together. So now the function is going to add 21, 17. Let's say we try to print this add function like this, and we run it. It only prints the thing from this function. And then when we try to print it here, it doesn't print anything because the function doesn't really have a value. It's not worth anything. Like if we try to print 1 plus 1 is equal to 2, that has a value. It's true. So it prints out true. However, if we try to print out this function, it doesn't have a value. We can give the function a value by using what's known as return instead of printing. So if instead of writing print x plus y, we write return x plus y. Now, when we print the function, it's worth whatever we put after the return. In this case, the two numbers that we gave it, here and here, added together. See, 328. And now, if we don't print it, it doesn't do anything because the function is only returning. It's only giving the function a value. It's not actually printing that value. If we want to print the value of the function, we have to use a print statement. And the thing about return, it doesn't have to even use the parameters. It doesn't have to be anything. It could even just be a constant number like high. And now this function is worth a value of high as a string. And when we print that function, it's going to print high. Thing about returning is that it's similar to breaking in a loop. In a loop, if you break out of it and then you try to do more stuff afterwards, it's not going to work. So you get the message that you're expected to end after the break. Anything after a break isn't going to happen. It just breaks out of that loop and continues on with the script. If you try to do something else after you've returned, like print hello, it's not going to work because as soon as you return, the function is over and it's done. So knowing this, some people just use a return as a way to exit out of a function earlier. You could even just return nothing just to stop the function early, and it'll print nothing because it's not worth anything. We gave it a value of nothing. But why would you want to use return at all? It seems like a waste when you can just print it in the function, right? Well, sometimes we want to use a function to do some calculations, and for that, it's easier to do a return. We can just use the result in a calculation. I'll show you an example. For example, I just made a little function here that it takes in a name and then it checks if the name is equal to eyes or if the name is equal to faith. And if that's true, then it returns true. And then I can later easily check if a given name is cool, like if of, then print cool club. I don't know, man. I don't know what I'm talking about. So what this is going to do is it's going to do this function and we gave it a name of. So is of equal to eyes? No, it's not. Is of equal to faith? It's not. So it's not going to return true. And we run that, nothing happens. And what about maybe eyes is cool? And it's going to check, is eyes equal to true? Yeah, it is. So it's going to return true. Ta-da! It prints out cool club. And yeah, that's why you might want to return if you want to do like a calculation or if you want to compare things, if you want to compare the result of a function instead of just having it live in the function world. Speaking of returns, one more thing you can do with them is you can return more than one value. I'll show you an example of a function like that. For example, I have a function right here and I want it to return multiples of whatever number I put into it. So we want it to return that number multiplied by 2, multiplied by 3. We'll just do up to 4. So whatever number is given to us, we're going to multiply that by 2. We're going to also multiply it by 3. And we're going to multiply it by 4. And now when we print out the value of that function, let's say we want multiples of 7. It's going to print multiple values of it. And let's say we only want like the middle value of that. We could assign it to different variables like this. For example, multiple A, comma multiple B, comma multiple C. And then equals, you can do multiples of 7, or it can be any number you want. Let's do the multiples of 5. Now we can just like print out one of them since this first variable is going to be assigned with the first thing that's returned, which just so happens to be the number multiplied by 2. The second variable is going to be the number multiplied by 3, and the third one is going to be assigned to the number multiplied by 4. So if we print multiple B, it'll give us 15, aka 5 times 3. Events are a way of executing code when a certain event is triggered. Similar to how properties and methods are attached to an object, events also are attached to objects. I'll show you some of the more common ones. We'll just name this part, make it into a cube. The touched event is only for parts and it just detects when the part has been touched. It isn't the most accurate thing ever, but for learning purposes, it's okay. The syntax for an event is the object workspace.part. I hope you notice that trend that you always go to the object that you want to access. With properties, we did that. With methods, we did that. And then you write a dot, just as you would if you wanted to use a property. But if you notice these lightning bolt symbols, they're for events. We're going to use the touched one. And then you write :connect, just because we have to. And then you write the function that you want to happen. Inside the parenthesis, it takes in a function of what it is that you want to happen. Let's just make a function that we want to happen whenever the part is touched. Remember how you make a function? Local function. And a common way of making functions for events is, since we're using the touched event, just name this function onTouched, parenthesis. And now we'll print the part was touched. And now we can pass on this function, and whatever we write inside of here is going to happen when the part is touched. So to recap, all events follow the same structure. You write the object, the event you want to happen after a period, capital C connect, followed by parentheses, and inside those parentheses, you write the function that you want to occur when that event is triggered. And I'll just show you what that looks like. I'll put this part up in the air, and when it touches the base plate, it should trigger the touched event, and it'll cause it to print. You see? And it bounced a little bit, so it fired multiple times. Whenever the part is touched by anything at all, it's going to be triggered, thus triggering this function. The touched event returns an argument for us that tells us what was touched, and we can access this by writing a variable in the function's parentheses. Normally for the touched event, people write hit because the touched event tells us what hit that object. And I'll show you, if I write hit.name, it's going to print out the name of whatever hit our little part here. You see? Base plate. So that event tells the function, hey, this is what hit the part, and we can access it by making the parameter hit, and then we print out hit.name to get the name of whatever hit it. I'll show you with my character too. Even if it's my character's right foot, left lower leg, whatever it is, I'm walking around on it, I'm touching it, it's gonna be whatever part touches that part. Another commonly used event is the player added event. This is an event for the player service. Yeah, services can have events too. So I told you it's for the player, so we access the object first. In this case, it's a service. So game.players, and I told you it was called a player added. And then I told you the connect, capital C, and then we have to write a function, but we don't have to use a pre-existing function. We can use what's known as an anonymous function. And we do this by just writing function in here and an opening parenthesis, but not the closing one, because the closing one is going to go at the end. Now, whatever we write from here to the end is going to happen whenever this is triggered. So whenever a player joins is when this is triggered. So whenever a player joins, we can print player has joined. See, player has joined. And similarly to how the touched event passes on the object that hit it, the player added event passes on the player. So we can name it player, but again, you can name it whatever you want. Player is just a commonly used thing. And now we can actually print out the player's name. You can print out some of the other properties, you can use methods on it or whatever, but this is just a tutorial. I only have a few minutes, okay? I'm just showing you like printing a lot. Be creative from there, okay? See, I printed out, I have eyes of faith. This function looks scary compared to other ones, but for events like this, I'd like to use this function, the anonymous function. It's just organizes things better, I feel like, for me. If you have multiple arguments, argument B, argument C, it's just a regular function. It's just built a different way and it doesn't have a name. So if you want a function that you can use more than once, don't do it like this. But if you have a function that you only want to use in this event, then you can use this method if you'd like to. And you can also nest stuff. We've already nested several things before, but you can nest an event inside of another event, which is pretty cool because the player just so happens to have a really neat event called chatted, which fires every time the player writes a message. And then we write function, remember the opening parenthesis, not the closing one, and then print player has chatted. So if we write anything here before this event, this is triggered when the player joins, remember? Joined. And then if we write anything in here, this is when the player has chatted. Yes, they did. So now we can test this out. You see it prints joined when I joined, and then when I typed hi, player has chatted, and yes, they did. Project time. I want you to make two functions. So the first function I want it to instance 10 parts. The second function, I want it to be able to take in an argument or parameter of message. Then it checks if that message is equal to the string of 10 parts, please. If that's true, then call function A. Then I want you to assign function B to a chatted event. And hint, you have to use the player added event first before using the chatted event. So pause the video now and then try it on your own and I'll show you my solution for it. Even if you can only do some parts of it, that's awesome. I'll help you out with the rest. So first things first, local function, I don't know, 10 parts, and it's just a simple function. We want it to make parts, and the way you do that is make instance.new part, and remember we have to give it a parent workspace, but we want it to do it 10 times, so we can use a for loop for this. For I equals 1 comma 10. We'll start at 1, go to 10, and end. The computer can handle doing it 10 parts just fine, so we don't have to put a wait. But if you want to put a wait, maybe if you're scared of your computer, I'm telling you, you'll probably be fine, but don't sue me, okay, if your computer crashes. And now we want another function. We'll call this onChatted, since we know we have to attach it to the chatted later on. You don't have to name it onChatted, but why not? So we made function B. It has to take in an argument of message. So we do that. When we write it here, it's called a parameter, and I think when we call it, it's called an argument. I could be wrong on that, so let me know if I am. We won't get into an argument about it. Anyways, then it checks if message is equal to 10 parts, please. So if msg is equal to 10 parts, please, then call function A. So call this function, and we just do that by 10 parts. Now we have to assign function B, aka this one, to a chatted event. So the hint is you have to use the player added before using chatted. So to do that, we do game.players.player added connect, and then we were going to do an anonymous function for this, just because we don't have a function already set up. And remember that this gives us which player has joined. Write player just to be different, and then player, when that player has chatted, we can use an event for that. And remember, for events we have to do $C connect after writing the event, and then we can go ahead and give it the unchatted message. When you assign a function like this, you don't have to give it the parentheses. So if we write 10 parts, please. Oh, let's go. The 10 parts appear. That'll be 500 Robux for my admin command script. Thank you. CFrame stands for coordinate frame, and at face value, it works pretty similarly to position. Right now we have this part on the base plate, and we can position that part using CFrame by just typing in workspace part.cframe, and it takes in a CFrame.new value, which is basically, well, it basically works the same way as a vector3 value, the x, the y, and the z of the position. So we said it's 25, 25, 25. See, it got teleported up there, and it's not anchored, so it fell. But yeah, you saw it move. But why do we have to do all this when we can just use part.position equals vector3.new 25, 25, 25? It literally does the exact same thing. See? Well, C-framing takes into account both position and rotation. Let me rotate this part to show you. If I rotate this randomly all over the place, as random as I can get, it's all tilted and twisted. If we use this line of code to change the position, it'll just move it over there, all twisted up and stuff. If we use the C-framing version, it takes into account the position too. And since we didn't specify the rotation with the C-frame, this just specifies the position. The default rotation is 0, 0, 0. As for when you switch the positioning, it keeps the same rotation that it currently has. But when you change the C-frame, you also have to specify the rotation. And if you don't, it'll give it a rotation of 0, 0, 0. And that's why the part is rotated to not have any rotation when you use C-frame, and why it doesn't when you use position. To specify the rotation, you have to multiply it using the multiplication symbol by CFrame.angles. The difference between C-frame angles and rotation is that it takes this value in radians. If you don't know radians, learn it. I'm not going to teach you. I only have a few minutes. But basically, pi is about 3.14159. That is about half a turn, or this is equal to 180 degrees. So this in radians is about 180 degrees. So this is like a 180-degree turn. If we divide it by 2, it's a 90-degree turn, which you still wouldn't notice on a cube. You know, it's symmetrical in 4 different ways. So we divide it by 4, this is like a 45-degree turn. You see how it's tilted like 45 degrees as opposed to like this? So yeah, C-framing is way better than using position and rotation in my opinion, and I'll show you why in later videos, but for now, let's just do some cool stuff with this. Like, let me just put it in a for loop. 3.14159. We'll make it go up by, I don't know, 0.05, and we'll have it wait. Because if we don't, then it's just gonna go from 0 to pi instantly. And I know it's not really pi, it's as close as I can get, okay? And we'll rotate this by I. So it should do like a half turn. Ooh, you see that? Pretty cool, huh? If you're creative, you can start combining some of the stuff we learned in the past and you can make some really amazing things. Now we're going to look at some potential scenarios using CFrame. Let's see if you can figure out how to do these scenarios. The first scenario is we want to move the part to 25, 25, 25, but we want it to keep its rotation. So we're moving this part to 25, 25, 25. But we want it to keep the same rotation using CFrame. Well, let's just assign this part to a variable first. And the way we do that is part.cframe equals cframe.new 25, 25, 25. Okay, so this teleports it to 25, 25, but it's going to get rid of its rotation because the default rotation is 0, 0, 0, unless we specify otherwise. And the way we specify that we want part.cframe to keep part.cframe's rotation, we multiply it by part.cframe.rotation. And this will keep the part's rotation, and it'll also move it to that location. See, the part kept the same rotation. So that's how you would go about keeping the same rotation. The second scenario is we want the part's position to stay the same, but we want its rotation to be 45 degrees by 45 degrees by 45 degrees. The way we do that is similarly to how we just did in the first scenario, but instead of keeping the rotation the same, we keep the position the same, obviously. So part.cframe equals part.cframe times cframe.angles. But remember, it takes in a radian, and nobody wants to deal with the radian. We can get close enough, 3.14. You can use 3.14. And that's 180 degrees. Divided by 2 is 90. Divided by 4 is 45. So we can just copy and paste this. And this will keep the part in the same location, and it'll change the rotation. So this won't really be perfect, but it's close enough, man. Third scenario is we want part A to have the same position and rotation as part B. So let me just make a part A and part B real quick. So now we have part A and part B, and we want part A to mimic part B's rotation and position using CFrame, of course. Let me just assign these both to variables to make life a little easier. So we could easily do this by setting part A.cframe to be equal to part B's.cframe. And this works for both rotation and position because remember, CFrame isn't just position or just rotation. It's both position and rotation. So this will copy both. You see, it took the same position and it's oriented the same exact way. The fourth and final scenario is we want part A to be 10 studs above part B. Well, this is a great way to start. And since we want to add a position to it, we can just add vector3.new 0, 10, 0 because 10 is in the y value. So it'll move it 10 parts above part B and it'll copy the same rotation as it too. You see, it is exactly 10 studs above it, and it has the same rotation. If we were to do this with position, it wouldn't copy the rotation, but CFrame is both rotation and position. Remember that. There's a wonderful thing we have here in Roblox Lua. It's called the math library. To access it is really simple. You just type math and then a dot, and then we can see a list of all the wonderful things we can use. I'm going to go through some of the simple and more common ones. Speaking of simple, if we use math.abs and write parentheses, I'm just going to print these all out so you can see what they actually do. Whatever number we write in here, it'll give us the absolute value. So if we write in 7, the absolute value of 7 is 7 because it is 7 units away from 0. The absolute value is just how far away it is from 0. This is more useful for like negative numbers to assure that you get a positive number. Negative 21 is 21 away from 0. Also keep in mind that for any of these, and anything that takes in a number in general, we can do calculations in here. Anything that boils down to a number, we can have in here. Yeah, as long as it boils down to a number, it'll give us an answer. Another one is math.floor. This is used to round down any number that you give it. What is 5.7 rounded down? It is 5. What is 5.2 rounded down? It is 5. And what is 5.5 rounded down? It is also 5. It rounds down to the nearest whole number. And if you're rounding down to all of these 5 point something, you can just get rid of the decimal and that's your answer. Alternatively, we also have math.ceil, which rounds up to the nearest whole number. So 5.5 rounds to 6. 5.2 rounds to 6, and 5.7 of course also rounds to 6. But what if you just want a regular round? Well, you can just write round. And now, let's see what happens when we do 5.7. Round it to the nearest whole number, up or down. It rounds to 6. 5.2 rounds down to 5. And what about 5.5? It's right in the middle. What's going to happen? What's going to happen? It rounds to 6. 5 and above, give it a shove. Math.rad takes in whatever you give it and converts it into a radian. Remember before how we use the CFrame.angles? If we wanted to convert this into a radian, we don't have to think of, oh, what is 45 degrees in radians? We can just write math.rad 45 and it'll automatically convert it into a radian for us, whatever that is. So you can use this inside of your CFrame.angles instead of trying to figure out what something is as a radian. And alternatively, we could use math.degree to turn any radian into a degree. For example, let me see how close 3.14 is to 180 degrees. It's pretty close. It's almost 180 exact. Two other cool ones I thought to show you was min, which you give it a list of numbers, let's say 70, 85, 2, 3, 4, 2, negative 6, and maybe 21.21, 21. So we give it a list of numbers separated by a comma, and it's gonna return the lowest one amongst all these numbers. Negative 6 is the lowest one. And if we do dot max, it returns the highest number amongst these numbers. And you can see how that can be useful. It's pretty cool. Again, you can use any of these math thingies wherever it takes in a number at. Let's cover some more cool math things. No copyright infringement intended. I meant like things in math that happen to be cool, not the cool math website. Anyways, math.pow is just another way of doing an exponent, like 3 to the power of 2, which gives us 9. And again, the order matters. So 2 to the power of 3 is going to be 8, not 9, because yeah, they're different answers. To do the opposite of this though, you can do math.sqrt for square root. And this gives you the square root of any number. Takes in one number like 225. What is the square root of 225? I don't know. Oh, it's 15. Tick, this little guy, he's not exactly a part of the math library. He's kind of his own little thing, but I thought it fit the theme. This is basically how much time in seconds has passed since January 1st, 1970. It seems like a really useless thing to know, but I'll show you a cool use of it. If we set local start of game variable equal to tick, it will let us know the time that the game started. We can then use this to see how much time has elapsed. If we task.wait, I don't know, a few seconds, and then if we wait a few seconds, we can then see how much time has elapsed since the start of the server by doing the current time minus the time at the start of the game, and then we can just print that out. See, 5 seconds has passed. Ooh, we can use this to see if task.wait is more exact than just regular wait. Ooh, task.wait is better because there was another 0 here. Ooh, just a little bit though. So yeah, this is a pretty neat thing you can use, and if you're creative, you can find more uses for it. Math.random gives you a random number. You put in the lower number and the higher number, and then it'll give you a random value between that range. For example, if we do 1 through 4, it'll give us a random number 1 through 4. And it happened to be 1. We can even make this a negative number and make it give us a value between -2 and 2, 0. Let's say you want a random number between 0 and 1. You can't really get like a decimal because it only prints out whole numbers. But what you can do is ask it for a random value 0 to 10 and then divide it by 10. Like let's say we get 9. 9 divided by 10 is 0.9. So that'll give us a decimal rounded to the nearest 10th place. And if you want like to the 100th place, you just make this 100 and divide it by 100 and so on. And again, if you want it between a decimal rounded to the nearest 100th, between 0 and 5, you can change this to 500. And yeah, there's creative ways to get things that you want. I hope this gives you an idea for any other scenario that might happen to come up for you. Let's go back to 1, 4. Something I want to show you is math.randomSeed. Computers are really bad at being random, so they have to base off the randomness off something pre-existing. We can assign that pre-existing number, but if you want it to be as random as possible, you should change it to something that changes. What is something that we could easily assign it to that happens to be a number that changes every single second? Tick. right. So if we assign it to tick, this helps more randomness in quotation marks for your math.random numbers. So I like to start off my scripts with math.randomC tick near the top in case I'm going to use anything random later on. Next two things I want to show you are constant. The first one is math.huge, and you're really not going to have much use for this a lot of the time. It's basically a really big number that's bigger than any other number. So for all intents and purposes, infinity, but like it's really not. Computers can't really handle infinity. You know this. Another constant. I'll show you guys so you can stop making fun of me because I can only round to 3.14159. That's all I know. But I don't need to know. I can just use math.pi and that returns pi or good enough pi, okay? Similarly to how there's a math library, there's also one for strings that lets you manipulate and interpret them. To access it, all you have to do is type in string dot, and then you have a list of all the things you can do with it. Let's go over some of the cool ones. First, I'll make a variable of string and I'll just call this hello. My name is eyes. Whenever we manipulate a string, I'm going to use str, which will be the string. Again, I'll be printing these out. String.find takes in two arguments. The first one is the string you want to find something in, and the second one is the actual string you're looking for. And once you have those two arguments in, it tells you at what position you can find that string. And we are looking for name, and it says 10 and 13. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's the start of name. 11, 12, 13, that's the end of name. It tells you the position or index of what you're looking for. 10 to 13 is where you can find a name. And let's say you don't want both 10 and 13, you just want one or the other. You can write in like starting point, comma, ending point equals, and you can assign each variable to each one. This will be to the starting point, and this will be assigned to the ending point. Starting point always gets assigned first, then the ending point. String.len returns the length of a string by character count. For example, if I have that string and I want to see the length of it, it's 22 characters long, and yeah, spaces count as characters too. A simpler way of doing this is just writing out the string and then doing a colon len. This method does the same exact thing as what I just showed you. It's up to you what you want to use. String.lower returns a lowercase version of the string. You see how we have capital letters here and here? Well, when we put it through string.lower, it makes it into all lowercase. On the other hand, if you want everything to be uppercase, you can do string.upper, and it will return an uppercase version of the string you give it. Again, like with the length, you could also do str colon lower, and it'll be the same exact thing as if you do dot lower, or you can even do the upper one too. These two might seem kind of useless, like why would I ever want a lowercase version of my string? Well, when people type in admin commands, for example, sometimes they type in kill with the capital, sometimes they have caps lock on type of kill, and then maybe they type in kill like they're supposed to. You can just turn it into all lowercase and check if it's equal to kill. You can check like if they type in, if you have message, you can turn the message into lowercase and make sure it's equal to kill, so that even if they have caps lock on, it still lowercases it to make sure it matches up with this. I'm sure the YouTube algorithm is going to love hearing me say kill, kill, kill over and over again, and I just said it more times. But anyways, string.rep takes in a string. Let's use LOL for this example. And then it also takes in a number. And this, it just repeats the string as many times as you specified here. So I told it to repeat it 5 times. Just combine my LOL into 5 LOLs combined. Alright, let's start off with an easy one. String.reverse. It just reverses whatever string you give it. Let's say I want to reverse this completely randomly generated string. Eyes of Faith is amazing. Oh my goodness, what in the world? How did that happen? That was just a random string, and it just so happens to be that in reverse. Wow. String.sub is just basically splices out a section of the string. It takes in a string, so let's give it the string we've been using. Then it takes in the first and last position, and it slices that section out. For example, let's slice out 7 to 17. It prints my name is, because the 7th starts right here, and the 17 goes up to here. So that's the part that it sliced out of here. That's what it does. You give it the string, starting point here, the ending point, and then it returns that section. Let's say I just wanted the eyes with the exclamation mark. Well, an easy way to do this is to start here and go to here. But we don't have to count all this. We can start counting backwards. 1, 2, 3, 4, 5. And instead of writing 5, we write -5. If we were counting normally with a positive number, it'd be like 1, 2, 3 from that side. But with a negative number, we start counting this way. 1, 2, 3, 4, 5. And to finish here, to get the last character, this exclamation mark, we want to end at -1. Because if you're counting this way, 1 in that direction is at the exclamation mark. So -5 to -1. And to print out eyes. String.gsub, you can tell it's already going to be a little bit similar. It can take in many arguments. The first one is the string you want to manipulate, of course. So str. The second is the part that you want to replace. So let's say we want to replace the string of eyes. And the third argument is what you want to replace it with. So change it to none of your business. And let's run that. Hello, my name is none of your business. So we gave it this string. It's looking for eyes. It's looking. Oh, I found eyes. And now I have to replace eyes with whatever this is. And it's none of your business. But there is a fourth argument that's optional. And I'll show you what I mean by that. Like, what if the string is B, 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 and I want to replace the B with an A. So let's say I want to replace the first 3 B's with an A. That's when we use the fourth optional argument, which is the replacement. It takes in a number. And let's say if we give it 3, it's going to look for a B, replace it, keep looking. Oh, I found another B. We got to replace it, and it's going to keep looking until it finds 3 B's and replaces them with an A. Let's look at that in action. Bam. This isn't part of the string library, but I thought it's really useful, and it's about time I showed you guys, long overdue to be honest. But if we want to combine these 2 strings into one, let's say string AB, all we have to do is combine string A and do dot dot string B. And now when we print string AB, it'll print a combination of both of those together. Hello world. It doesn't have to be variables, of course. Any string you put in here, like whatever. And it'll combine, just do 2 dots, and you can combine as many strings as you'd like. Project number 6. What I want you to do here, first make a script that makes 10 parts fall from the sky when a person types rain. The note, give the parts a random position. I'd use CFrame for this, but you can do whatever you want. But give the parts a random position, except I want you to give the parts a height of 100, and then give them a random X position and a random Z position from -100 to 100. And you should be using CFrame for this. So go ahead and pause the video and try it on your own, and then I'll show you my version of it. So I didn't really give you much to work off of. I just gave you one instruction, but if you like the little headings and then splitting it up by section, you can obviously just split it up yourself. So you know, I need to check when a person types rain, and then you need to make 10 parts appear, and then you gotta position the parts randomly. You can split it up just by reading this. You can make a list of everything that you need to know, of everything that you have to do, and this can help you organize it. So I'll just keep what I had originally and work from there. It'll be fine. So we're gonna have to check if a player chatted, but before we do that, we have to get the player. And a way to get the player is just using the player added event. So we're going to do game.players.player added connect, use an anonymous function, and we're going to get the player. I'm just using PLR to show you that you can name it whatever you want. r.chatted. When the player has chatted, I want to use a function. Anonymous again. We'll name it MSG capital M just to show you that it can be whatever you want again. Now we have to check if the player types rain. So if message is equal to rain, then the problem with this is that the player has to type in capital R rain. If they type in rain like this, it's not going to work. But if we don't want capitalization to matter, we can make this into lowercase. Remember that the message is whatever the player typed, and doing this method will make it lowercase. So if their lowercase message is equal to lowercase rain, then we gotta make 10 parts. Whenever you want to do something multiple times, you know it's a for loop. 1 to 10, do, and if we don't specify the third number, the increment is 1 by default. And let's make the local droplets. You can name it whatever. Instance.new part, and we're going to put that in workspace. And droplets.cframe equals cframe.new. We want, let's do 0, 0, 0 for now. We want the Y position to be 100. I said to give it a height of 100. I want the X and the Z to be random numbers, -100 to 100. And remember, we do random numbers by using math.random, and then the lower number and the bigger number. And then we can just copy and paste that here. If some of you guys are really good at remembering things, you might remember that I said that using math.randomSeed of tick helps the randomness feel a little bit more random. So let's go ahead and test this out and see if it works. Don't mind the parts from before, please. So I'm gonna type in rain. Bam, random parts. That's pretty cool. What if we type in rain because we're mad? All caps still works. What if we do capital R? It still works. What if we spam rain? It's raining. Oh my goodness, it's a thunderstorm. Oh my. Survive the natural disaster. Who? We got this game. This game is way better. It's not. So this is the end of the intermediate section. I hope you've been learning in an engaging way and having fun along the way too. And I appreciate you for making it this far. At this point, we're just about 2/3 of the whole thing done. So let's go ahead and finish this last advanced section. We've been nesting things inside of each other for a while. I mean, look at this. We have a for loop inside of an if statement, inside of an event, inside of another event. But when you do it with for loops, it's a little bit more complicated, or any loops really, but especially for loops, we can look at that and understand it better. But why would you want to do this anyways? Why would you want a for loop inside of another for loop? Well, essentially, you want to do this whenever you want something repeated, every time something else is repeated. And it sounds a little bit crazy, I know, but let me give you an example. Let's say this is you and this is me. And for some reason, you want to walk around this block 3 times. But every time you go around the block, you also want to smack me 5 times. So what is that going to look like? I'll just make a little chart up here of the times you've gone around a block and the times you smacked me. So you go around the block 1 time, that's 1, and then you smack me 1, 2, 3, 4, 5 times. Then you go around again, that's 1, then you smack me 1, 2, 3, 4, 5 times. And then you go around once more, and then you slap me again 1, 2, 3, 4, 5 times. You see how you're repeating that one action, the slapping, for every time you complete another looping action, which is going around, because you're repeating going around, but you're also repeating slapping me every time you go around. Let me show you something interesting you can do with this that doesn't involve me getting damaged. Let me make one for loop for row equals 0 to 100, going up in increments of 5 to, and then we want to instance the part. Local part equals instance.new part, put it in workspace. And let me just make this part into a cube by changing the size to vector3.new 4,4,4. If we want to position this in a row, we can just do part.cframe equals cframe.new and set it equal to row 0, 0. So what's going to happen here? The first one is going to be put at 0, 0, 0, and it's going to loop around, make another part again. That second part is going to be put at 5 because it incremented 0, 0, 0, and then the next one will be put at 10, 0, 0, and they'll be put all in line. You see how they're all lined up in a row? So when I equals 0, then 5, then 10, 15, 20, and it goes up to 100. If we put another loop inside of here for column, and we make that equal to 105 too, and indent everything properly. We'll set this one equal to column. Can you guess what's going to happen here? It makes a whole grid, a 100 by 100 studs grid, almost. But why does it do that? I'll show you by putting a wait right here. We'll wait 0.1 seconds. So it does everything on one row, then it goes up to the other one because the column increased. After the whole row is done, the column increases by 5. So it pushes it up and does the same thing over, but with 5 more increased in the column. And then it does it again, until it reaches 100. And bam. It's a 20 by 20 grid. Obviously, if you do even another one, it'll make it 3D if you put it into the other axes. But just add a wait. I don't want you guys crashing, but I don't have much time to go into this. I'm running out of time. Just make them anchored if you do the y-axis. This is just a little thought experiment that I think you guys would find interesting, and hopefully it gets you like creative juices flowing. I don't know why I said that. I always thought that was a weird saying, and now here I am. I didn't have anything better to say. But yeah, try some cool stuff out with this. I think you could do some awesome stuff, man. I still haven't convinced you to use the C-framing instead of position or rotation? Okay, fine. Let me show you some other things you can do with C-framing then. One thing you can do is easily make a part rotate to look at another part. Like we have part A right here and part B right here. Let me move it over here, over here. Let me move this guy over here, over here. Actually, I'll put a decal on part A on the front. I put a decal on part A just so you can see what way it's facing. And if we want part A to look at part B, all we have to do is this. Part A.cframe equals CFrame.new. We write part A dot position because we want it to keep the same position that it currently has, comma, part B dot position because we want it to look at part B's position. And now when we run it, oh, let me anchor this. Now when we run it, you can see that part A is now facing and looking at part B all creepy like. Doesn't matter where part B is, this will work. It'll look at it all creepy like. You see that? I got my eyes on you. Another thing we can do is position things in front of other things relative to their rotation. I'll show you by using the parts again. I'll add a decal on part B also. Let's say we want to move part A in front of part B. We can use something called a look vector, and I'll show you how it works and then I'll explain it. We want to set part A's CFrame equal to part B.CFrame plus part B.CFrame.look vector times 25. And I'll show you what happens when I run this. In the direction that this part is looking, it'll go 25 in front of it. Even if you rotate it this way and this way, now it's facing that way, it'll still be positioned in that direction. No matter what way this part is facing, it'll go in front of the part it's facing. The way this works is, we want to change part A's CFrame to be the exact same as part B's, but we want to move it in the direction that the part is looking at. That's what this part basically means. Plus, it's just adding the direction it's looking at and then how far ahead you want to move it. If you just want it a little bit in front of the part, you can make it 5 studs in front. See that? If you want it really far, you can do 500 studs. Oh boy, that's far. Wow. You could even make it behind the part if you make it negative. It'll just be in the opposite direction, behind the part. See, it's facing that way, but the part is behind it. And the really cool stuff about this is that you could also use up vector for the other axes, and it'll be above it. And there is no down vector, but again, you can just make it negative, and it'll be beneath it. And again, for the last axis, there is a right vector. If you make it positive, it'll be to the right of it, see? And if you make it negative, guess what? It goes to the left of it. The last thing I want to show you is lerping, and we're going to need another little part for this. There's the little part. What lerping does is it finds a specific C-frame that's in between 2 points. For example, I'll use part A and part B to represent 2 points, the position of part A and the position of part B. And if I want to find the midpoint between these two, I can just do part C.CFrame. This is the part that I'm going to use to indicate the midpoint, equals part A's C-frame, and we want to lerp that or interpolate. I think lerp is short for that. Don't correct me if I'm wrong, I'm sorry. And we want it part B. So what this is just saying, we want part C C-frame to be somewhere in between part A and part B C-frame, dot C-frame. And then where exactly along from part A to part B? If you want it to be halfway, the second argument takes in a number 0 to 1. So 0.5 would be the halfway mark. So as you can see, the midway point is not only halfway distance-wise, but it's also halfway rotation-wise. I think using a for loop shows us better. For I equals 0 to 1. So I put in a for loop, it's going to go from 0 to 1, going up by 0.01 every time. So you can see, like, if this is 0, it's going to be all the way at part A's C-frame. When it gets to 1, it'll be all the way at part B's C-frame. Let me put a weight so you can actually see it happen. Not only is it moving positionally, but also rotationally. Tables are basically just a list of values. You make them similarly to how you would a variable, but instead of writing out the value right after the equal sign, we put brackets, and that's how you make a table. Like a variable, you do tab equals, but instead of doing like true or whatever, you just write these brackets, and that's a table. The video's done. Just kidding. We can put any values we like into this. We just have to make sure everything's separated with a comma. Well, what do you mean we can put anything? I mean anything. We could have numbers, we can have strings, we could have Booleans, we can have a part, we can have anything we want. You could even have other tables inside of here, but we'll get into that in the future. Just make sure everything's separated with a comma. But I used to be so confused by tables back in the day. I'm like, when am I ever going to need a list of values? Well, a lot of times, actually. But if you want a list of disasters for your disaster game, maybe you have a tornado, you have a hurricane, you have a cyclone. Maybe you have a list of these very, very diverse disasters for your disaster game. Let's use this disasters example to show you what else you can do with tables. If we want to access any one of these values in the table, I'll just print it out in this case like I do with everything else because I'm keeping it simple. I only have 5 minutes, leave me alone. We just type the name of the table, followed by square brackets this time, and what number it is. Like if we want tornado, we type in a 1 because it's the first object. and it'll tell us tornado. If we want cyclone, it's the third object, so we write 3. Do you think you can figure out a way to make it print out a random natural disaster? Well, put in your math.randomc tick in there. Yeah, just to be safe. Then you want to write disasters, and in the brackets you write math.random, and then you want a number from 1 to 3, and that'll give us a random disaster. Tornado. So that means that the random number that I picked was 1. But what if, we're really good game developers, we want to update the game. We're going to add a typhoon. Now we have to change this every time? Nah, let me show you a little secret. If you write hashtag disasters, this is equivalent to however many items are in this table. How many items are in this table? 4. So this is automatically is 4. When you write hashtag and then a table, it'll return the amount of items in that table. So if I type in wind, now it's 5, and it'll still pick a random one, even including the new ones I added. I mean, this time it picked hurricane. It's making me look bad. Maybe this time it'll update and pick one of the picked hurricanes again. Okay, maybe this time it'll pick one of the ones I added. Typhoon, there you go. And I didn't have to change this. I can just keep adding more disasters. There is also a table library, like I showed you for math and string, but I know if you figure out the math one and the string one, you could easily follow along with table, especially the string one because, yeah. Generic for loops are a way of iterating through tables. That just means going through all of the items in it. Why would you want to do this? Maybe you want to look for the highest value in there. Maybe you have a list of every player and you want to give them all an item or something. Could be a lot of reasons. So let me just show you how to go about doing that. Let's say we want to look at every disaster in our table. You do for I, v in pairs, and then you give it the table, in this case disasters, because that's what we want to go through, and then do, and yeah, you start the loop with 4, and then these two variables, they can be whatever you want, but I and V are the most common things you'll see, and that's for a reason, because I stands for index and V stands for value. What is index? Index is the number of the position of the item. So this loop is going to go through every item on this list. It's going to start at tornado, then go to hurricane, and go to cyclone. When it starts off at tornado, the index is 1 and the value is tornado because that's actually what is put in the first slot. When we get to here, can you figure out the index and the value? The index is 2 because it's the second thing in the table, and the value is hurricane. And then you just write in pairs because you have to. And disasters is the table we're dealing with. Let me print out I and V so you can see what this loop is doing. The loop is going through a table. First I is worth 1, then tornado. Then the second time it loops around from the start, the I is 2 and the V is hurricane, 3 and cyclone, 4 and typhoon. Then at the end the I is 5 and the value is wind. There are some methods that actually return tables. So let's say you want to look through all of the children of workspace. There is a method that gets all of the children and puts them in a table so that you can put table in the for loop and then look at all of the items that are inside a workspace. That method is get children. It returns a table. So we can look through it using a for loop. Let me show you. First object in that table is the camera, then the base plate, then terrain, then a script. So if anything returns a table, you can look through it using a generic for loop by putting it in the parentheses after the pairs. From here, you can do whatever you want. Like V, in this case, the value is the camera, and then the base plate and the terrain. You can do whatever you want. You can try to change the name to Eduardo of every child of workspace. You can manipulate whatever you want. Let's look. Yup, they're all named Eduardo except terrain. It's being difficult. Maybe you can even destroy it. I don't know why you're going to name it if you're just going to destroy it, but you can try destroying it. Good luck. And yeah, it destroyed as much as it could, but we cannot destroy terrain, so we got an error. The value is the actual object, so you can even change the properties of them. If you want to change like the position, make sure it's a part. You can do if v dot class name is equal to part to make sure it's a part, and if it is a part, then you can change the CFrame because you know that won't give you an error because you know that if it is a part, it has a CFrame. So we've looked at tables in which we put values in, and the values are basically assigned to an index on the table. The first value has an index of 1, and so on. We can do something similar to that, but instead of numbers, we use a variable called a key. A dictionary is basically just a list of keys with their assigned values, and I'll show you what I mean by that. Let's say we have a table of our players cool. And in here, we have eyes, but eyes not very cool. And we have faith. And faith is cool. So you see how this is different from a regular table? A regular table, it would just have the value. In the dictionary, we have a key, and then we have that set equal to a value. Now let's try iterating through this dictionary with a for loop. And we're going to print the index and the value. Remember before when we did the disasters and we printed the I was 1 for the first one and 2 for the second one, and then the value was whatever the first value was, whatever the second value is. Let's see what it prints this time. Instead of printing 1, it prints I. We're basically saying instead of worrying about the location of this, instead of worrying about the index, this is basically the new index now. Now, let's say you wanted to print the first value. How would you go about printing that? Well, for a regular table, we would just write the name of the table, square brackets, and then the position of where the first value is located. Like this one would be the first one, this one would be the second one. But here, maybe you figured it out. Instead of typing in the index, we're going to type a dot and then the key for the first one is going to be i's. And let's print that. It tells us i's is equal to false. And of course, if you wanted to figure out what this value was worth, faith, we would just type in faith there instead, and it's true. So you can see dictionaries really aren't too different. It's just that the values, instead of being linked to an index number, they're linked to a key that we decide. And we can make this whatever we want. And then we can check whatever is whatever. Something cool that can be done with dictionaries is nesting tables within them. For example, if you have a list of players, and this is a table, you can space it out like this for better organization. And let's say you have eyes of faith, but you want him to have multiple values. Just set that key equal to a table, and this table can be its own dictionary. Like maybe it has a gold value equal to like 5. Don't have much gold. Maybe it has a level value, I don't know, 7. And you have to separate it with the comma because this is a table. So try to figure out if you can figure out how to print my level. Well, we have to go inside the players table. And then the player, we have to go to the next level, which is this table, eyes of faith. And if we wanted to print out the level value, we just hit level. So this is one way that dictionaries can be useful. And also you can have multiple players. But again, remember the comma, like someone actually cool. And they can have their own stats like this. You can give them a lot of gold. Level, just a level 1. That's just how cool they are. And then you still access them in players, but instead of going to Eyes of Faith, we'll go to someone actually cool and print out their gold. Wow, they got a lot of gold. These values are usable. Like you could go inside the players table and go to someone actually cool and look at their gold. And you can set that equal to whatever his gold is minus 500. That will take 500 away from his. And maybe you want to give it to someone a little less fortunate than him. So set my gold equal to whatever my gold is plus 500. And now we can print out my gold. Ha ha ha. Started at 5, now I'm at 500. Let's go. So generous. So this circle in the middle is the server. What does that mean? Everything that you put into your game, like buildings and maps, anything that every single player sees and interacts with, that's in the server. And this little C you see around here, this is you. If you want to play somebody's game, you are connecting to a server. And if you're playing with your friend, you're not linking up directly to your friend. You're linking up to the server, and the server is also linked up to your friend. It's linked up to everybody. Your own computer is known as the client. And the client, which is your computer, deals with things that you see like GUIs and your user input. For example, if you input something, your client has to communicate that to the server. They're not like one and the same thing. And the way that we deal with stuff in the server is by using regular scripts like we've been using this whole entire time. But if you want to deal with stuff that happens on the client side, you have to use what's known as a local script. Remember how I told you should put scripts in server script service? That's because they're known as server scripts, and you can put them in workspace too. But for local scripts, you should put them somewhere that replicates for each player that joins. If you don't know what that means, it's fine. Just put them either starter character scripts or starter player scripts. If you want the script to reset every time the player dies, put them in starter character script. But for most cases, I think you want to put them in starter player scripts. But I don't know what your life is like. For server script, we only need one because there's only one server. For local scripts, these are going to be duplicated every time a new player joins, and they'll be gotten rid of when a player leaves. Let's just put the local script in the starter player script for now. Local scripts are pretty much just like regular scripts. You can see from the hello world, it says the same thing. You can also insert them through the model tab. This is for regular script and this is for local script. the blue one. So yeah, when you go inside the local script, you see this hello world. Don't be scared. If you never used the local script before, don't be scared. The only thing is that everything that happens on the local script only affects the player whose that local script belongs to. You'll understand what I mean as the more we do this. So something cool we can do with the local script is access the player directly. We don't have to use game.players, blah, 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 blah. We can access the local player that the script belongs to by assigning any variable, and we can do game.players.localPlayer. We print the player's name, and I go ahead and join the game. It prints my name. Because if you look inside players, inside my player scripts, click this local script, you see this local script got cloned into here from starter player. You see, we put it in here, but it gets cloned into a player when they join the game. And if you were to join on your end, you would see your output would say the same thing, but I wouldn't be able to see your output because, like I showed you before in the picture, we can't communicate directly. We have to communicate through the server. So that's one of the main takeaways I want you to have from this. Everyone has their own local scripts, and it gets duplicated when they join, and anything we do on the local script will only affect the player that the local script belongs to. This seems overly complicated, but it's really necessary because it makes things safer, and Roblox knows what they're doing. Don't question them. Sometimes you should question them, but I don't know what I'm talking about. Time for project number 7. There's going to be 2 projects in here, so we'll go over the first one first. Make a table of any colors you'd like. Then I want you to make a 20 by 20 grid of parts. And finally, I want you to assign a random color to each of those parts from your table. So pause it now and I'll show you my solution when you give it a try. So first things first, we have to make a table of color. So colors tab equals, I don't know, let's pick like 4 colors. Grid color dot new. Let me just copy and paste this so we can just see the Roblox colors. Okay, let's go with gold. I think gold will look good with white, and I think it look good with black, and maybe even a little red. Sure, really red. Now we gotta make a grid of 20 to 20 parts. These parts can be as big as you want. They can be spaced out as much as you want. I just keep it simple for I equals 0 and it's comma 20, and we'll go up by 1 so we don't have to specify it. And this is gonna be the rows, and then we have to do another one for the other axes. For J, we'll just use a different variable. We'll also do this the same dimension, and now we have to make the part local part. It's not new part in workspace, and let's just anchor the part just to be safe. And now we have to space them out in a grid sort of way, and we can just do that by part.cframe equals cframe.new, and I want it like flat on the floor, so we're not gonna use the y-axis. That's gonna be the one that gets left out. Now we have to assign a random color to each one of these parts from the table. So we can make the parts.brick color equal to, we have to choose a random color from this table, so we can do colors tab, and then for the number, for the index, we would do math.random 1 through whatever the length of the table is. And if you remember the math.random C tag, make it feel a little more random. Actually, let's just put a weight in here just because I like to see it happen in steps. Let me make the parts size equal to vector3.new 1 by 1 by 1, so they all fit nicely since we're going in increments of 1. Wow, this looks like a piece of art you find in a modern art museum. It does look cool, but like it's not anything. So yeah, that's what the result should be for your project, but maybe you picked some cooler colors than I did. I don't know. The cool thing about doing it this way is even if we're like, we don't want the red anymore, we still don't have to change anything else. We just remove the red and that's it. You see, your next project, make a table of at least 3 fake players and set those players equal to a table made up of stats like gold and level and stuff like that. Just any stats you want. I want you to print out their names and levels. So first, let's make this table of fake players. fake players equals, let's do eyes of faith. And don't find it weird when you see tables split up like this. It's just another way of writing it out. Now we want to set those players equal to a table made up of stats. To make them equal to a table, we just set the equal and then we write a table like this. And what kind of stats? I mean, I just wrote gold. Let's just do gold and level. Why not? So gold equals 0, level equals 0. And just copy and paste this. We can just copy and paste this for the other two. And now we can give them some arbitrary stats. So I just gave them some random stats, and now if we want to print out each of their levels and their name, this part might have been a little tricky for you to figure out, but it's just a table. If we want to go through fake players, we just have to use a for loop, pairs, and then the table we want to go through is fake players. Then do. So if we want to print out the names, you would have to print out I, because remember, instead of the index, the key is now the I value. So let's just run that real quick. See, I, faith of. So this is the value of I's. If we want to print something inside of I's, normally we do fake players dot I's dot level. But since we already have I's accessed and we have all of them accessed, we can just write v dot level since they all have a level value. You see, I's is -5, faith is pi, and of is 17.86643. Remember how I told you before that clients and servers need to communicate with each other? And there's many situations where you want to talk to the server, like if you have a user input something, like if they press the E key and then you want an attack to happen. The attack will take place in the server, but the user input is controlled with the local script. And the way we do that is through remote events. Remote events are just an object that let local scripts communicate with the server scripts, and the server scripts communicate with the local scripts. To communicate from a local script to a server script using a remote event, first let's insert a remote event into replicated storage. Replicated means that it can be accessed through both local scripts and server scripts. So just put the remote event in the replicated storage. And to communicate from a local script to a server script using a remote event, we have to use one of its methods called fire server. So first let's just do local re equals game.replicated storage.remote event, and we have to use the method fire server. And it basically just sends a message to the server from whatever client sent it out. Let's look at how we receive this message on the server script. On the server script, we still have to access that remote event game.replicated storage.remote event, and we use this by using an event on server event. So when you're on a server script, you use the on server event because you're listening for when a server event happens. Then you do your typical event stuff, function, and bam. Now we print server has been triggered. So let's just go ahead and run this and see if it works. The server has been triggered. So again, to recap, this line of code right here, it's just the local script telling the remote event, hey, tell all the server scripts that I sent a message. And then this event right here is listening, hey, whenever you get a message, do whatever's in here. And I'll show you, like, we could even wait 3 seconds and it won't happen until 3 seconds later because it's actually working. See, when you go from a client firing to a server, it actually passes down an argument, and that argument is the player that triggered the event, and then we can then access that player and do things on the server side with it. We could print out that player's name, for example, player.name, wait 3 seconds, and server has been triggered by I have eyes of faith. Even though we didn't pass down an argument in the parentheses here, when you go from local script to a server script, it always passes down the player that triggered it. And I always just print out the name, so let me just show you some other stuff we could do. Like, you could access the player's character. Player.character. And the character is like the physical representation of the player in the Roblox game. So like your R6, R15 bodies, that's where your character is. From the character, you can access its humanoid, and it has a health property. You can set that equal to 0. There's a lot you can do once you have the player and the character on the server side. Also, you can like teleport him or her using the humanoid root part and changing its C-frame to whatever you want. See that? To do this the other way around, from the server to the client, we still use the remote event, but this time we use a fire client method because we're firing to a client. But we have to specify which player in particular we want to fire it to. So yeah, so you'd already have to have gotten the player in some sort of way, either from listening to one client and then getting the player, or using a event to get the player, or you can get the player in many ways. You already have to have had a player. Let's just assume you already have a player. How do you listen to it on the local side? You listen to it pretty much the same way. You go to the remote event, on client event, of course, and then your typical event stuff, then function, except this doesn't pass down a player by default because we know where the message came from. It came from the server. There's only one server. If we get a message from a client, there's multiple clients, so we have to know which client it is, but the local script doesn't need to know where the message came from. We already know it came from the server. And then we can print eyes of faith client was triggered. And since I don't have a player right now, I'll just show you something else I could do. You could fire all the clients, and this will send a message to everybody's local scripts in the game. I'll show you. I'll join in the game. Oh, by the way, if you just run the game, the local scripts will not work because remember I told you that the local script has to be duplicated inside of a player to work. So that's why I'm always playing now. Oh, it didn't work. That's because server scripts load faster than the player because you have to wait for the player to load in and the character load in. By the time this local script is listening, the server script has already loaded. So let's just wait 5 seconds and give it some time to load, and then fire all the players that have joined after we give it time to load. And bam, it was fired or triggered. I'm going to show you how to make things happen when a key is pressed, and from there I'm sure you have learned enough to do everything else, like when a button is clicked. I only have 5 minutes, okay? There is a service that handles user input. It's called user input service. Let's just name it, I don't know, UIS equals. The way you get services is by using game get service, and then you type in the name of the service. And I just told you it's user input service. There are many events we could use for user input service, as you can see right here, that detect when user input has begun, such as like pressing down on a button, or when it's ended, just letting go of a button, stuff like that. But for this, we'll just use input began, so when they press down on a button or they click down, it could be any sort of input. And then we do our generic event stuff. We'll do anonymous function. This does have arguments that we can use. First one is the input type, and that just lets us know what kind of input the user has began to use. It is an enum value, so hopefully you remember that from back in the day. It's pretty simple if you don't. So that input type argument just gives us more information on the type of input that has just started. We can check if the input type dot user input type is equal to keyboard input. And the way we do that is input type dot user input and check if it's equal to the enum of user input type keyboard. Then print keyboard is being pressed. Let's go ahead and test that out. You should always be testing your stuff to make sure it's working constantly because you don't want to write like 200 lines of code and then have it not work. So I'm moving out around my mouse and it's not printing anything because that's not a keyboard, but as soon as I walk around or I'm typing, you see, it works. So a keyboard is being pressed. Now we want to check if the key being pressed is the key we want. I don't know, let's just pick Q. Q's right there, you know. And the way we check if it's Q is like this. If input type dot key code is equal to, again, it's an enum dot key code dot. Here you have a list of all the key codes. We just want Q. Then print Q was pressed. Let's see if this works. I'm walking around and it's not detecting it like it was before, but if I press Q, ooh, it works. Now we can use our remote event to make things happen in the server where every player can experience something, like maybe spawning in a part. Because if I just spawn in a part using a local script in here, then only this player is going to be able to see that part. But if I want every player to see that part, I got to do it through the remote event. So re.fire server. So this is going to send a message to the script. We can make the script detect when a server event has happened, do a regular event stuff, and let's instance parts, man. And let's just print the player's name so we can hold whoever set it accountable. Whoops, capital P. As you can see, I'm pressing Q and parts are being made. As you can see, this is very cool, but if we're typing Q, 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 it's still spawning. If we don't want that, we have a second argument that checks if the player is like doing something else like chatting or in the menu. So if they're like chatting, we can just call it chatting. It doesn't matter. And chatting is equal to false. So, and they're not chatting or in the menu or something like that, then fire it. Else, don't do anything. See, it works fine. And now if I'm typing Q, it doesn't spawn in parts. I'm not sure if you've been noticing these last episodes, but I haven't really been teaching you anything new per se. Like this is just an event. These are just if statements. This is just a method. This is just stuff from before, but put into a new light, I guess. All this seemingly complicated stuff is just a combination of the fundamentals like data types, functions, events, and so on. So let's look into the camera basics to keep up our practice with the fundamentals. Do you think you're going to use a local script or a regular script for the camera? If you guess local script, you're right. Every single individual player has a camera and they control it, so it's going to be a client-side thing. We can access the player's camera through a local script by writing workspace.current camera, and that will take a hold of the player's camera. One of the cool properties that cameras have is the field of view, and we can change that with the script as we would any other property that takes in a number. But let me put it in a for loop. Goes from 10 to 100, and let me show you what that does when you go from 10 field of view to 100 field of view with the weight, of course. Whoa. Pretty cool, huh? Something else you can do is just change the camera type. I'll show you here. You can click the camera in the workspace and see all the properties. You can change the camera type. By default, the camera just follows the player around where they go. You know how regular Roblox default camera works. But we can change this using an enum. For example, if you want to control every aspect of it and you don't want the camera to do anything, set the camera's camera type to it's an enum camera type to scriptable. And let's give it a little bit of time for everything to load. See me walking around just fine with the camera until the 4 seconds is up and the camera just stops doing any sort of work. Ooh, 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 ooh. Changing it to scriptable gives us a lot of freedom, and we can move the camera around by using CFrame. For example, if I want the camera to become scriptable and then I want to wait another 4 seconds, and I want the camera to rotate to look at a part. I wonder if you guys remember how to use CFrame to make a part look at another part. That's just how we're going to do it for the camera, except instead of a part, we're using the camera. Camera.CFrame equals CFrame.new. You give it the position of the camera, and you can access the position through the CFrame if you write cam.cframe.position, and then the position of the part, workspace.part. So what this is going to do, player's going to join, and that's when the local scripts start. Server scripts start when the server starts. Local scripts start when the player joins. And it's going to wait 4 seconds. Then it's going to turn the camera to scriptable. Then it's going to wait 4 more seconds. And it's going to make the camera C-frame keep its same position, but look at the part's position. And let's just see that in action. So the part is over there. Let me just look in a different direction. And now it's going to wait 4 seconds. And bam, it looked at the part, but I can't stay away from the camera. The camera loves me. And yeah, you can manipulate the C-frame just as you would any other part. And look at all these camera properties. I know you want to mess with them. Go mess with them. There's a service called Tween Service, which is really cool and simple to use. What this service does is it takes a starting condition and an ending condition, and it changes the object as you specify. First, I'll show you by using it on a part in a server script. So we have this part right here. To get the service, you just do gain get service. Tween service. First, I'll show you how to create a tween. A tween is kind of like its own data type thing, and we use the tween service to do that. TS, and then we create, and this takes in 3 arguments. The first argument it takes in is the object that you want to manipulate. In this case, it's the part. The second is the tween info. This is just a unique data type, just like vector3 or color, but unlike those, this one takes in a lot of arguments. I'll go over them briefly because I trust you guys can understand them. Let's name it tween in. And to create it, all you have to do is tweeninfo.new. And first argument is a number of how long you want the animation to last. Let's say you want it to last 5 seconds, and it takes it in seconds. The second is an enum of the easing style. If you don't know about animation, it's okay. You can just look at these and you can mess around with them and try them out on your own. Let's do cubic. Third is easing direction. If you don't know about easing style, probably don't know about the direction, but it's really simple. If you mess around with it, you'll figure it out. Let's do in and out. The fourth is how many times you want it to repeat. So set it to 0 if you don't want it to repeat at all. This is a repeat, not how many times it's going to do it. It'll still do it once, but it won't repeat it. The next argument, you don't have to do all these arguments, by the way. This one is going to be a Boolean on whether you want it to reverse after it's completed. Like it'll go through the whole animation, and then if you want it to reverse what it just did, you set it equal to true, but I don't think I want that, so I'll equal it to false. The next argument is a number in seconds of how much you want to wait for the animation to play after you tell it to play. I want to do it right away, so I'm just gonna make it 0 so it can start right away. So once we have this looking how we like it, all this tween info, we can set it in as our second argument. Our last argument for this create method takes in a table. The table should be structured as follows. I'll just name it local tab. It should be structured like this. The key is the properties that you want to change. For example, if you want to change the part size, that should be the key if you want to change the size. And the value should be what you want that size to be equal to. So let's say vector3 dot. You want this to grow big. 30, 30. And remember, it's a table, so you have to put the comma at the end to separate the values. And then maybe you want to change its position to, I don't know. You can pick any property you want as long as it belongs to this object that you said right here. Once you're happy with that table of properties and values, you can set that table in as the third and final argument. So once we have our tween done, let's set that equal to a variable, and we can play it by accessing it and then using the play method. And I'll show you what this looks like. See, whoa. Pretty cool. And I showed you all this on the part because now we can do this on the camera, because using the tween service to move the camera allows for nice fluid animations. I just copy this stuff and I'll put it down here. But we can't change the color of the camera. We can't change the size of the camera. Instead of changing the part, we're going to change the camera. And instead of position, let's just use CFrame equals CFrame dot new 50 50. You see it moving to 50 50 50 all smooth like for 5 seconds. And I hope you can see how this is useful. You can make it to make some cool cinematics for your game or intro screens, whatever. We're on project number 8. And now for this, I want when a player presses X on their keyboard, I want the field of view to increase by 10. And also, when they press X, I want the base plate to tween to a random color, size, and transparency. So go ahead and pause this, try to figure it out on your own. After you've tried it on your own, I'll show you my solution for it. So we want to check when the player presses X first. So we have to get the input service, game get service, user input service, UIS.input began, connect function, and this is for the inputs, and this is for the check if they're chatting or on the menu or whatever. So if they're not chatting, and inputs.keycode is equal to, what key do we say? X. enum.keycode.x. Then I want to increase the field of view by 10. That's a local script thing. Let's go ahead and access the camera. Cam equals workspace.current camera. And we want the cam.field of view to equal the cam.field of view plus 10. And then we want the base plate to tween to a random color and size and transparency. Well, if we do that here, only this player is going to see that happen. We're going to see that happen to every player. We have to do it through the remote event and tell the script. So to access the remote event, remote event, and we fire a message to the server. So we know we're going to need the tween service. So let's just go ahead and get that out of the way. And get the service, tween service. We want to check when the message is going to get here. So we're going to need the remote event too. We want to check when the message gets here with the events. We can include the player argument just for practice, but we don't really need to do anything with it. And now we want to make a tween that makes the base plate into a random color, size, and transparency when the player presses X. So remember, we need to create a new tween, and it takes 3 arguments. The first one is the object we want to manipulate, in this case, the base plate. Then we got to give it a tween info. So info, let's make this stuff local. So info equals tween info.new. And you can make this whatever you want. I just set it to something I think would be nice. And once you're happy with that info, just pass it on as the second argument. And then we need to get the table of the values we want, the table of the end goal of the properties. So we want the base plate to tween to a random color. You can do that by changing the color to equal a color3.new. Give it a math.random from 0 to 255, but you have to divide it by 255 so you can get it, because remember it takes in a number 0 through 1, and we'll copy that for each value. And I'll be surprised if you guys forgot the math.random seed tick. I mentioned every time we have a random number and a random size. size equals to 3.new dot random. What's a reasonable size for a base plate? Let's make it go from 100 to 700. Or that axis. The middle axis, I don't want it to be too thick. We'll make it go from 1 to like 100. And then this axis is fine. Oh yeah, don't forget the comma. I always forget the comma. But Roblox won't let me forget. And transparency, this one will be easy since it's only one random number. The random 0 to 100. We can divide that by 100. I just forgot about the comma while I was talking about forgetting about the comma. Space this out a little bit so it looks nicer. Goal. And let's set this equal to tween. And now we can play the tween finally. All this will happen instantly. It'll go right down to the tween and play it. So let's see if this works. So I press X, the field of view changed, and so did the base plate. And I press X again and it changes again. And the field of view changes. It looks like I'm zooming out, but I'm not. Whoa. This is actually so cool. Only I could see it well with this field of view getting wild. Actually, I think the field of view is helping me see it better. This is pretty cool stuff, man. This is awesome. GUIs, aka graphical user interfaces, are those images that you see displayed usually on your screen, and they don't move around even though the camera moves around, and they ask you to buy Robux and stuff. You know what I mean. Let me show you the different types and how to use them. First, you want to look at the service starter GUI, and in there add a screen GUI. If you want anything displayed on the screen, you're going to need a screen GUI, and you put that inside starter GUI because this will be duplicated inside the player. Every time a player joins, whatever's in here will be put inside that player, and then that player can see. That's why it's called starter GUI. Whatever you put in here, the player will start with. The most basic type of GUI element is a frame. Let's go ahead and add a frame, and you can see it at the top left. A frame is typically used as a background or to hold other elements inside of it, and you can put like another frame inside of that frame. You can nest them inside of each other. If I make the size small, see, you can put frames inside of each other. And now, if the outer one gets moved, the inner one will move with it, stuff like that. You can nest GUI elements, as long as it eventually leads up to screen GUI. Next element we're going to add is a scrolling frame. This right here, you can see it's very similar to the regular frame, except this one has a scroll bar, and if there was stuff inside of here, we could scroll through them. But yeah, it's basically the same thing. This one can't scroll, this one you can scroll, you can see the scroll bar. The next two we're going to go over is the text label and the text button. The text label is used to display text. As you can see, it says label right here, and then you can customize it to say whatever you want, and just to display information like next round starting in 5 seconds or whatever information you want to let the player know. This is a text button. You see when you hover over this, it changes and the label doesn't. That's because the button is used for interactivity. If you want the player to click on it, if you want to detect when the mouse hovers it, and yeah, if you want the player to interact with a button, make it a button. If you just want to display information, make it a label. It's the only difference. They both display text. The image label and the image button are basically like the text label and the text button. The image is used just to display information, not for people to click on it. Like maybe the players voted on a map and you want to show them a picture of the map. You can use an image label. But if you want them to click on that image, say maybe you have like a icon to buy your in-game currency, then you want to use an image button. As you can see, when I hover over the label, the mouse stays the same. If I hover over the button, the cursor changes. And then you can detect when the player has clicked or whatever. So right now I have spaced out the frame, the scrolling frame, the text label, the text button, the image label, and the image button. But there are more ways to display GUI elements than just using a screen GUI. The screen GUI displays it on the screen, but you could also display it on like the surface of this part. Let me show you. If you take this part and add a surface GUI and then put all these elements inside of there, nothing happens because you have to find the right face. So this is placed on the front face. So let's find the front face. Oh, there you can see it. And let's go ahead and put it on the top. And now everything fits, and we'll get to that in a future video. I hate when people say that, like, oh, but we'll go over it, don't worry. You can see all the same exact stuff that I had on my screen on the parts. It basically just takes the part surface and pretends it's a screen. The last way is to put it inside of a billboard GUI. And I'll just go ahead and put it in there to show you. Let me make this part transparent. And yeah, you can see how it displays the billboard GUI no matter which way I'm facing. As long as I'm looking in this direction, it'll show it to me. And there's lots of properties you can do, like always on top. And then if I bring this part back, even though it's not transparent anymore, it'll always display the elements on top. I just changed the size of it so you can better see it. I'll go over that later. But yeah, you can see if you want something that's always displayed, it's kind of big. That's how you go about doing that. So I'm going to be using this frame and just add it like I showed you in the last video. There are two ways to size and position the GUI elements. If you go on the properties of the frame, you see this position property. These first two numbers, the 0 and this 0, they're for the x-axis, and these two numbers for the y-axis. Let's focus on just the x-axis right now. The first number is known as a scale, and it takes in a number 0 to 1. 0 being all the way on the left side of the screen, 1 being all the way to the right of the screen. If I change it to 0.5, it moves the GUI, it moves the frame to halfway across the screen. 0.5 is 50%. 0.25, a quarter of the screen. 0.75, 3/4 of the screen on the x-axis. And if I set it to 1, you can't even see it because it's pushed all the way across the side. You can just barely see it. But let's go ahead and set it to 0.5 again. Even if the screen size changes to be tiny, it'll still start at that halfway point of the screen. So you can see an advantage of doing this is that it works the same on different screen sizes. Even if it's small, it'll still be 50% or whatever other percent you put in. This second number just moves it pixels. Like if you want to move it 100 pixels to the right, type in 100 pixels. Maybe you want to move it 250 pixels to the right, move 250 pixels to the right. This is known as the offset. If we resize the screen now, notice how the frame stays right where it is. It doesn't nudge at all, it doesn't move. And that is why there's two methods for resizing GUIs. Sometimes you want to position them so that it scales, and also you might want to add a little like offset. You can use a combination of both. Like you want it to move 50% of the screen, then you want to move it 200 pixels to the right on top of that 50%. And you can see how that looks. And for the y-axis, it works the same way. You can do like 0.25%. And then you can also move it a certain amount of pixels. Maybe you could even do like -10 pixels and it'll go back up 10 pixels. Yeah, you can combine all four of them. Let's move it back to 0 on every axis. Let me show you the size. And let's make the size 0 on everything too. The size works the same way. First number is the percent. So if we make this 0.5, 0.5, you see it takes up 50% of the screen in the x-axis, 50% in the y-axis. And it also scales up with it because the percentage is based on the screen size. If I scale it, it scales along with it. And before we had it at 100, 100, and you saw that it was a nice little box. Notice how it doesn't scale because it's just pixels. Pixels are the same size no matter what the screen is. And again, you can combine, like you want it to be 50% of the screen plus 100 pixels or minus 100 pixels, and there you go. You can combine multiple of them. So yeah, sometimes you might think if you do 0.5 and 0.5, if you make these numbers the same, then it'll be a nice perfect box. Like if you do 100, 100 on the offset, it's a nice perfect box. But remember, it's based on the screen size. If the screen size is not a perfect square, then 50% of one axis is going to be longer than 50% on the other axis. I mean, if I made this into a perfect square, then the frame would be a perfect square too, but I don't know any square screen sizes. Keep in mind that most people's screens are longer in the x-axis. So let's go ahead and just insert an image button. You could do an image label if you want text. But I just want to show you how to make something happen when the button is clicked. We've been through a lot of events already, but what's one more? You can actually put a local script inside of this element and the local script will still work because remember I told you all of this is replicated into the player also. So to access the image button, that is the parent of the local script, equal button equals script top parent, and that's accessing the button. And there are many events like mouse button 1 down, which is when you left click, mouse button 2 when you right click, when the mouse has gone up, when someone's touched it, when someone has tapped it on like a tablet or something, or just activated is for when the button's activated by any means. I always thought mouse enter was cool, so let's go ahead and use that one. It's triggered when the mouse enters the frame. You see when it changes up to the different hover cursor. We don't need any of the arguments for what we're doing. And if we want something to happen in the server, you know we need that remote event. So I already had mine in replicated storage. And let's go ahead and fire the server. And on the server script, we also need to get the remote event. And I don't know, what do you guys want to see happen when the server is fired? I don't know. Maybe we can just change the base plate's anchor to false. I like chaos. I'll go ahead and play the game. And when the player enters, oh no, the base plate is falling, but it's hard to tell, but it's gone now. And I'm gone now. Oh, and if you were to hover it again, it wouldn't work because base plate deletes itself after it's fallen too far. So to fix that, you can check to see if base plate is still a child of workspace by doing if workspace find first child and then a string of the name base plate. So if base plate is a child of workspace, then we can change the properties of workspace.baseplate. You can see we can hover over it the first time, and now that it's deleted, we can still hover over it and not get any errors. Alright, something else we could do, since we get the player, and then we can get the character, local character, goes player, player.character, and from here we can access the humanoid, which has a lot of properties, including walk speed. We can set that equal to whatever the walk speed is, plus 10. And now every time you hover the mouse over the image, the walk speed will increase by 10. Oh, walk speed is spelled like this with a capital S for speed. So I hover over it, you see me walking, I'm a little faster, faster. Go fast, go faster. Down. Ah! This is the 9th and final project. For this, I just want you to make a frame appear and like go up like woo when you hover over this. Actually, when this is clicked or tapped or anything. That's all the instruction I'm giving you. Let's see if you can do it. If you happen to have this from last time, it's a good starting point. So pause the video now and try to do it on your own, and I'll show you my solution for it. Okay, so we don't need that. We're just dealing with on-screen things. The menu that's going to appear is going to be on the player screen, so everything we do is just going to be on the local script. We'll still access the button, but instead of when the mouse enters it, we're going to check when it's activated. We are going to need the little menu, but it's not going to be a real menu. I'm just going to do a frame. I'm going to size it to be, I don't know, 40% of the screen, 0 pixels, and I guess like 80% of the screen, no pixels. And I want it in here. I'll scooch it over to the side by 0.3, and I want it to start at the bottom, so I'll start it at 1. So it's all the way at the bottom down here, and we won't be able to see it right now. And we'll name this menu. So let's go ahead and get that. We'll go menu goes button right here, and we're going to do the parent of that and then get the menu. Button.parent.menu. So now what do we want to happen when the part goes up? Well, I want to change its Y value. So we could use a for loop for this. And right now, the value we want to change is the position, which is 1. So we want the I to go from 1 to maybe, I want to go maybe like to 10% of the screen up here. So that would be from 1 to 0.1, and we could do negative 0.05, I guess. And then I wanted to wait because I want it to happen not all at once. So I wanted to wait every time it moves up a little bit. And the way we position the menu is like this. Menu.position equals. It takes in a udem2, and then it's essentially like changing the property. So we want to keep this 0.3 so it doesn't move anywhere from on the x-axis. 0 pixels, and we want the y value and scale to change, and still no pixels on the y-axis. Don't forget to put it's udem2.new. I'm a bad teacher. Sorry it took you till like the second to last episode to realize, but yeah, udem2.new. Everything's .new. We're making a new position. Now when we activate it, bam, wait, this is lower than I thought. Why? Change it to 0.05. Okay, that's better. This is nice and all, but if we click on it a lot, it glitches out all over the place, spazzes out, because you're starting a for loop, then another for loop, another for loop, another, and it just gets bad. To counteract this, we can use what's known as a debounce. You can name it whatever you want. Set equal to false. And now when we activate the button, we can check if debounce is equal to false. Then set it equal to true. And then we can set it equal to false again once everything is said and done. If you ever want to auto indent it perfectly, you can just format selection and then hit here or Alt Shift F, or you can just format the whole document. For an even easier way, Control A to select everything, Control C to copy, and then paste it in again, and it'll do it for you. What the debounce does is, while the debounce is true, it won't play. It won't make the for loop restart again. So it waits until the for loop is over, and then it changes debounce to false, and then it's allowed to make this condition be able to be true. So I'll show you that working now. You see, I'm spamming it, and it only goes up 1 time per loop. Just think of it as, is the animation playing yet? No, the animation is not playing right now. So we only want the animation to play when the animation is not currently playing. So that's why when we start the animation, we set it equal to true, like animation is playing. And when the animation is done, we set it equal to false, like telling it, hey, animation is not playing. And if you want to do a cooldown, this is where you put a wait. Should be using task.wait, but whatever. You can wait 5 seconds, and now I won't be able to activate it for 5 seconds after. See, I'm clicking it now, it doesn't do anything. It's going to wait 5 seconds. And then I can do it again. If you also wanted it to go back down, you could just make another variable, menu open we start off with the menu not open. So let's set that equal to false. And then if the debounce is false, then we can check is the menu is not open. Then we want to run this line of code, this for loop, so that it opens it. Else, this will take into account if the menu is not open. We want to do the opposite of this. So go from 0.05 to 1. We have to go in the positive direction. And let's not wait a whole 5 seconds. I forgot to set the menu equal to something. And then when the menu is open, we play the animation and then make the menu open equal to true, because after the animation plays, the menu is open. And in this case, the menu starts off being open, but then after we play the animation, menu open is equal to false. So let's go ahead and play that. Bam. You see how it doesn't go all the way down? We could just add a little bit more to the final value to make sure it goes all the way under. See, much better. And you can do this with Tweening service, it'll be smoother, but I just want to show you something real quick as our final little project. Alright, this is the end of the series. I hope that helped you. Please do me a favor and leave some honest feedback of anything you liked or disliked, or anything that helped you learn, or anything that was confusing. If you have any suggestions whatsoever about anything Roblox game development or Blender, anything at all of a future series you'd like me to do related to that, or video ideas in general, I'd love to hear. Seriously, I love ideas. But I really appreciate you watching this whole series. And if you didn't and just skipped to this last video, then at least watch this one all the way through, okay? Psych, but like, unless you want to, I won't mind. But yeah, let me know what you think. I hope this helps. My first series, I guess. Never really taught like this, so sorry if it's bad. Must be bad for you to watch this whole thing and then you now realizing it's bad. Like, wow, how many hours is that wasted of your life? Sorry, I'll do better next time, or at least I'll try. I can't promise I'll do better, but actually I don't even know what I'm talking about right now. I have my hair not attached to my head. You're probably thinking, now what? There's a lot of good content on YouTube. There's a lot of good content on the internet in general. And I feel like this course has given you enough that you can go and learn on your own now. Because you have to know enough to learn. Like, if, I don't know, let's say you want to destroy a part, and then you Google, how do I destroy a part? Say, oh, just use the method, part destroy. You're like, I don't know what a method is. Well, now you know, now you got that foundation that you can go and learn anything else, I feel like. So good luck with that, and let me know the cool stuff you make. God bless you. See ya.